Hello and welcome, lads and ladettes, to the Friday Twitter community space. Shout out to the lads and ladettes that have been holding it down while Flat Earth Fridays has been on break. These guys are troopers. All right. We're going to go ahead and join now, see what the boys are up to.
Building to building, door to door, with a bucket of.
Here, Dr. Heffron's idiot British science and don't see Oh. If you're trying to speak, though, you're muted.
Testing 1,
He's
2.
probably trying to get up there.
Testing 1, 2.
There he is.
Yep.
There he is.
Hola, senors.
Whoa.
How are you, lads and ladettes,
I was-
tonight?
I was not looking, so I was like, Ether Cos, wait, Toby's in here? And then everybody started talking about Alan. I'm like, what the hell?
Oh man, I miss Tobetheus. Hope he drops in
I
one
miss
night.
Toby.
He's been, dude, Sheep. He was on Earth Awakenings. Rumor has it earlier in the week, chopping people up, dude, just dicing them. They call him the slice and dicer now.
But yeah, I'll let you do your spiel, Alan. I'm sure everybody's got questions, but dude, I have to tell you about. I don't even know who I'm arguing with anymore. Like, is it Zidney or Globe Chick? I'm pretty sure it's all the same person.
Yeah, it's all.
But yeah, like I don't understand how you can say that a star is refracting up above the mountain when you can't fucking see the star anymore.
Oh, dude,
Yeah,
dude. We can get into all of that. I've been working on a little spreadsheet, and I've been learning so much about the data and what it shows in comparison to what the raw globe predicts, what the refracted globe predicts, and what the celestial refracted globe predicts. And like, it's wild out there in the streets. So, like because it's really two methods being like that I'm analyzing, right? So the Heffron method would be analyzing the raw globe versus the true position, because that's what we're doing flat earth, like we're doing raw flat earth for raw globe 1 for 1. So analyzing it through that, the globe is horrendously off, and that's what the J value showed when it because like I didn't understand the purpose of it, because it seemed like it wasn't like it just I was like you can't just align it like that, but it's for like it's literally whatever the globe would exactly predict, it would be adjusting it against that, and it's just like then they're like it makes it very obvious like what the discrepancy is. But I've been looking at it with the refracted positions and all of that from observer location, and comparing the differences and comparing the difference in true position in mountain peak when the star is occluded. And I found some really interesting things that show our point about the occlusion being physical, because it happens at the intersection point. And one second. And not before. So like, to give a good example of that, there's measurements that are indistinguishable from what the globe would predict using the refracted position. And the reason that they're ambiguous there is because the refraction is lifting up the star twice or triple the amount for curvature to compensate. And then with that, you have it's basically it's equal to double or triple the amount of what they would expect for drop. So they're way off to begin with, unless they do this refraction thing where it makes the apparent position just happen to line up with the true position at the peak at the same time. And when that happens, the angular difference in position and physical difference between the peak and the mountain, the mountain's true position is like it's usually between 4 arc seconds and I'm sorry, 4 arc minutes, and then down to arc seconds on other examples. So it shows that that occlusion point is physical. Now, in the example for Blend Mountain, for Jesse's example, if their refraction worked the way that they claimed it does 1-to-1, the star would have emerged sooner than when the true position intersected with the peak, because it would have already been refracted over the peak and it would have been sooner. So like when you go through this data and look at it, dude, you can like when you go raw to raw, it's the globe can't win because their triangle's smaller. Like it's just they're like it's GG. When you refract, you can get places where it's ambiguous because of the basically the amount of expected drop. If you convert it into an angle, the celestial refraction angle and correction is either double the amount that's expected for drop, or triple, or equal to. And so, but the intersections though happen at that at that physical point within like a 4 arc second tolerance on the ones where it's ambiguous. So we know our methodology is sound. We know that refraction will affect the measurements, but it's still going to give different results. So when we go to areas where the difference in refraction isn't equal to the globe drop, it we can see the discrepancy there, and we can still derive our true position. So externally, when we use the system without telling Stellarium where we're at, we can more closely approximate our position going raw for raw versus what they can do. And that shouldn't be the case. They should be able to go raw for raw. And that's what Mike's spreadsheet was about. Just adjusting just comparing to where the star would be if it was the ideal globe intersection and how much it's off from that. And like, that makes it glaringly obvious. But like, yeah, dude, they literally exist within a refraction tolerance that's insane. Because one of the other things that I learned that you can do with these angles and distances, you can see like the amount, how much refracted, like lifted up the object. So for example, if they expect 200 meters in drop, for example, over this distance, and the refraction coefficient the refraction difference is 16, you can get the angle that or you can get the amount in meters from the refraction angle times the distance, and that will tell you how much the refraction lifted it up. And so remember, they expect 200 in drop over distance, but then the refraction based off of that distance and angle relationship that gives them like 600 meters in elevation. Like, dude, dude, the ratio that they do, like, it's always like triple, double, or equal, or damn near equal what they predict, or it'll be off by like 50, 60 meters. But yeah, it's so crazy. So, but the physical intersection process, dude, they don't even come close. So it's been a real fun process going through it and looking at all these points of contention and stuff, because I'm sure everyone that's been following it's been like, what's going on with the analysis? Are they steel manning the globe? What's a double drop compensation? I have no idea what the double drop thing is, but all I know is when I put in the way that Mike was deriving the raw globe, it was exactly how the other mainstream globularist proponents were deriving what the raw globe was, and then they wanted to add in terrestrial refraction to it. And the reason terrestrial refraction isn't relevant for this experiment, because here's the thing, right? They want to add in, it's basically 7/6R, but converted into meters per degree. So what they want to do, like for example, for Pikes Peak, it adds 2 arc minutes to the quote unquote raw globe, and so in Pikes Peak, it doesn't really skew the measurement that much because the discrepancy there is greater than the refraction. So it doesn't matter. It doesn't help them enough. So let's see here. What was I going to say? The refraction, Pikes Peak.
Well, don't they take a different tactic with Pikes Peak?
Oh, sorry. Hold on. So it doesn't add up to a lot in Pikes Peak, but for other mountains where it's kind of close because of the refraction moving the position closely to the true position, and the ratio of distance times the angle affects how much it's going to impact it. So like just adding that too on different measurements adds more ambiguity to it, because it gives them a better ratio to be closer. But the thing is the celestial theodolite, right? The refraction on the light between the star and the mountain peak is all we care about, because when we no longer see that, that's the angles that that's where we're referencing everything from. The physical elevation, the physical elevation due to refraction, if you were to like optically measure between the peak and us, we don't care about that at all, because the occlusion timing is what we're referencing to get our angle. So the angle for that is going to be what it is. So it doesn't affect how we're analyzing like the actual raw geometric globe. Like we're not strawmanning the globe at all. Mike ingeniously came up with a way that removes refraction, because even if it's refracted up due to terrestrial refraction, it doesn't matter. The time that we don't see it is the only thing that matters. And that's such an important concept that even when I was going over this spreadsheet, I had fucking forgot, because I was focused on trying to like figure out what was being strawmanned and how do I best represent it. And I was like, I'll add it. I was like, when I added it to Pikes Peak, it didn't add that much of a difference. So I was like, okay, it's fine. But then I realized like the ratio of distance and the angle, determines like actually how much impactful it is. And then when these measurements where the globe was off, suddenly it became a measurement where it was ambiguous when you did that, but we're not referencing the same geometric position that actually matters relative to the measurement for the true position comparisons. So that's like the important distinction of this, is like the argument's kind of been blurred a little bit, where it's like, is it about this refracted position? What is it? This is about the raw geometric position, and we both derive the same exact raw geometric globe. The refraction between us and the peak doesn't matter, because the time that it's not visible, that doesn't change the time it's not visible, because the time it's not visible is when the refraction on the other side of the mountain is no longer able to affect the physical intersection of the star to peak. And that's when because like that's what all the measurements where it's like real ambiguous show for the peak intersections. Like the difference is in like 4 arc minutes to arc seconds. The ones where the refraction has to make up the difference just because it has to, they get into like 8+ arc minutes to 18. It gets preposterous. There's even like when you get to the North Peak data, there's a 40 arc minute difference. That's basically just saying, hey, it's definitely a globe, trust us. That's it. And even that amount wasn't even enough to help them. They were still off by 200 meters, and they predicted actually that the star was 11 arc minutes under the horizon. So you know how they're always like, where's the star beneath your feet? They predict that the physical light source was below the globe, and it was still being refracted up and over the mountain. Like, dude, get out of town, bro. So and then so they come up, so they have a preposterous difference in true position and refracted position of 40 arc minutes. I mean, that's, dude, if you can't, like, if that doesn't show you how it's obviously derived as a coefficient curve fit, then nothing will ever be falsifiable to the globularist, and they'll just always accept it. But that difference is crazy, because we know from the other measurements that the intersection point, like when that threshold crosses, it's within like 4 arc minutes. It doesn't get, the ratio isn't 1-to-1. That's insane, because if it was 1-to-1, Jesse's emergences would have been sooner, because it would have been visible before the intersection peak had crossed the peak. So that they're inconsistent. This whole thing has completely obliterated the globe. Like it's so crazy to look at the differences. But yeah,
Yeah, if refraction was a thing, Alan, you're right. He should have seen the star pop over the mountain sooner than
and
what was
yeah,
expected.
yep. Yeah, and the way that they want it to be with the 1-to-1 ratio, it would have already been seen, and it wouldn't work that way. So,
You know what they're arguing right now?
What's that?
Like I've gotten a few of them arguing, Zidney and a few others. They're arguing that because Dr. Heffron said that he had a direct line of sight to the star, that he's saying that that was a straight line to that star. And I'm like, bro,
I mean, we can
if
draw.
I have,
I mean, dude, it's just a tangent. We're just drawing lines to fucking like it. It
I
doesn't.
don't even think he meant that. I think he was talking about, maybe he did, but I don't know. When I hear someone they have a direct line of sight to a star, like as an example, if someone told me I have a direct line of sight to the sun, I'd be like, oh, you don't have any clouds in front of you? Because as soon as a cloud gets in front of you, it's no longer a direct line of sight.
Yeah, it just means you can see it.
Right. But and then the other thing I wanted to say too is like, okay, so the time that the star disappeared, right? Like the fact that when you turn refraction off, it puts it in the same exact location as when the star disappeared. It's like, wait. So that means there's no refraction going on when that star disappeared. So basically you're saying that 30 seconds ago, before the star disappeared, that was also the true location, that it's not being refracted over the mountain. Like we could take it just a few seconds before it disappeared,
Right.
and that's also the true location, because what's 30 seconds in the whole mix-up thing? Or 15 seconds, we could go 15 seconds. That probably wasn't being refracted also. That was probably the true location. So my question is this: they say that there's some kind of refraction happening all the time. I disagree. In any data set, 0 is always an option when you're talking about real numbers. So there's a possibility that when you're looking at something, you may not be looking at the apparent location, or that apparent location may also be the actual location as well, because there may not be any refractive properties happening at all. So I just wanted to throw that out there for y'all as well.
Yeah, in this case specifically, that's not what we're saying at all. We can show how.
No, I'm not saying.
No, I know. I just wanted to be clear for the lads, because people will say they're denying refraction. Like no. We can specifically show the relationship between physical occlusion and like refraction reasonably, versus this is just what it had to be because
it's demonstrable.
Yeah, like because otherwise the other measurements, like you said, would have came up sooner, or would have been occluded sooner, because the true position would have hit it sooner. So that's.
But when you turn refraction off, and then it's in the exact location that you're observing, that's pretty fucking damning, dude.
Yep. Yeah, I couldn't believe it when I went over the Mount Blend measurements, and then I was at observer location with apparent, with refraction on, and it was at 1 degree or whatever it was, let's just say 1 degree. And then I go to the mountain peak with refraction off, and it's at 1 degree. I just died laughing. I was like, all right, dude, I see what you did here, because their true position at the mountain is 20 arc minutes, so they literally just like refracted up by 20 or 30. It's like, okay, dude, that's great.
Yeah, and what happens when you turn refraction on in that observation?
It shows that it's at the same location as the true position on the with the peak.
So there's no difference with refraction on or off?
The difference is really small. That's why it's like,
oh, okay.
That's why it doesn't give, like, when they say like, oh, it gives globe results, it becomes so minuscule. Like we're talking like in some examples, it's like a 50 meter difference, or 30 meter, or like 100, and the sky moves at 30 meters a second. So it's like,
right.
Like, like what we're dealing with here is like a close measurement for when it's quote unquote globe, when the globe's off, it's preposterously off, and flat Earth isn't off like that. Like we're always closer, and especially,
I got you.
and that's comparing the refracted positions for my analysis. When we do raw for raw, like GG, it's we had a good game.
So would you say in that observation, and I see your hand up, this will be my last thing. So would you say in that observation then that it may appear, I'm not saying that it's actually happening, like the further discussion and observation needs to be made in order to determine this, but it may be such minimal refraction that it's close to zero?
No, it's not what I'm saying at all.
I just trying to clarify. I'm trying to learn, man. I don't know the ins and outs of all of this and everything, but I feel like I'm getting a grasp on what the observation is
Yeah,
and understanding it. I just don't understand it at the level that y'all are reading at.
yeah,
Because y'all are nerds and I'm not a nerd.
yeah, we're saying that there's like a reasonable tolerance for like how far something can be below an object before it's not visible anymore, and it seems to be around 4, maybe 5 arc minutes. Like to be generous, I would say 5. And then when you get into these examples where they're 6, 8, 18, 40, 20, that's where it's just like, okay, this is what it had to be because it's a globe and it makes up. And then when you ratio out what their drop over distance is versus the refraction lift, it's like they're equal to or they're double or they're triple the amount of expected drop in lift. Like that's like dude, you're living in a virtual reality math simulator. It's you're referencing a curve fit at that point.
So before we head on over to Huff real quick, you're not trying to dodge anybody's objections or anything like that, any challenges to this as Ruhif wants to claim?
No, I actually, if you go to my spreadsheet, I'll leave a link here in a second. But I'm in the middle of overhauling it, so the first page looks pretty disgusting. So like I can ignore that. But every other sheet, you can decipher what I was getting at there. I'm adding whatever globe angle anyone wants or how they want to calculate it. I'm adding all of it and comparing all the methods. But keep in mind, the true actual Heffron method is comparing raw for raw, not the raw for not for the raw and plus raw refracted. That's not because that part of the analysis isn't valid to our observation because we only care about when the star isn't visible. Like what they want to do to make it equal to whatever the mountain would be at the time. Like we don't give a that's not it either lines up or it don't. We only care about the celestial angle. So
absolutely no running from space audits.
nope, and I will add anything to the spreadsheet anyone asks as long as it's like reasonable, like I'm not going to add some crazy stuff. But check this out. What I did add earlier, I added a way to derive the distance using spherical trig, doing like all the radius stuff. So like there's even a raw estimate for what the raw globe would give doing spherical trig, and then I do one or yeah, that's basically like getting like the chord length, and then I have a great circle arc as well for distance. So like I'm trying like to whatever their best possible scenario would be. I'm doing it all, man, and they're not even like it's like I said, it's not even close when you do raw for raw. The refracted stuff is fun for comparison because you could see how they fudged it.
I mean, if you're doing what they're asking, I mean, you can't really be strawmanning them, right?
Nope.
I mean, so yeah, there's Ruhif. You're just over everything today. So,
Well, I think the straw man part, at least from what I've seen today, because Ruhif's been atting me when he's talking to Shane. Well, he's been talking to me too. But isn't he trying to change? He wants the stellarium from uh Heffron's house now.
I already have that
Because
I already have that in my analysis. No, that's the entire backbone of my spreadsheet before I even adjusted to the terrestrial refraction thing that they also want. I've got comparisons for all that. That's already in my thing. And even
Well,
in go ahead.
what I don't understand, and I mean, I know that's what they want, but we're using a mountain to occlude a star, and it's the
Yep.
mountain that's occluding it. It's not anything near us at Heffron's house. It's at the mountain. That's what's occluding the star. So they're wanting to bring it back 50.7 kilometers. They're not only bringing it back 50 kilometers, they're also changing the elevation of the observation because the
Mm.
mountain's higher. So I mean, they're changing the distance and the elevation
Yeah,
and
and
trying
even
to get.
and even with that, it didn't help them much. It only gave them some measurements where it gets ambiguous because they're close because the refraction puts it at the same intersection point as the true position. So like
What?
that let me show you this, right? Let me put it like
It took
this.
them out a minute
In the instances
ago. He doesn't
where
want to stay because it's raining.
I know. Did you take him out on the leash and walk out there with him?
Yes.
you're hot micing, bro.
I don't know
You got a
why
hot
he
mic
did
there,
that.
Ken.
So yeah, in the instances where it gets indistinguishable between the two because of the intersection points and the refracted point, the globe, like flat Earth will be off by 47 meters. Globe is closer by 16 meters. And again, the sky moves at 30 meters a second. Their expected drop over distance for this location is 100 meters. Like this is not the ideal spot to be like, oh, dude, like if I were a glober, right? I wouldn't hinge my flat Earth refutation on a measurement that where it's like, because when I was going through this and going through the different values for the this refraction versus what stellarium would have measured if you were the observer on the ground, referencing the apparent position and all that. When I was going through all these numbers fluctuated back and forth between flat Earth and globe by tens of or 20s of meters, and it's just like at that point, because we know that it's a physical intersection process at locations where refraction location is close to the apparent position, it's not it's going to be ambiguous or indistinguishable. That's the only way they can go raw for raw, because they're close to the raw position. So
you can see the some refraction in the timing measurements, or no?
yeah, absolutely. What a reasonable celestial refraction difference in between apparent position and refracted position. So what I'm comparing is I take the true position at the mountain peak, and I take the refracted position from the observer location, and I just subtract that from the mountain true position, and then that tells you the difference between the intersections as an angle. So, for example, in most measurements, it's like 5 arc minutes angular difference between intersection with the peak and no longer being visible for the lad on the ground. And those are those seem to be like real actual refraction conditions, where it's like, okay, it had to get lower than the object because because it was being refracted over a little bit. And that's exactly what Goose showed in his in that rig that he made with the Dow and the light source, and lining it up with no medium in between, and then showing where the light source was when you add the medium, and you could see that the position had to be lower. So it results in a different time. But the question is, how much? Like, how much lower can that thing get before it's just like, okay, now it's 40 arc minutes below, and somehow it's still just a globe, guys. Like, you know what I mean? So like when it gets over 5 or 6, I think that's where it gets unreasonable.
Yeah, so how many equations for globe predictions do you have now? Do you know?
Well, let's see here. I have the way to derive drop over distance using Jesse's method, where you convert the drop into an angle and then subtract it from the flat Earth angle. I have the raw trigonomet or the raw one from Mike, where you do 360 times the distance over 2 pi r, which gives you an angle, which you subtract from the raw flat Earth prediction. Oh, I'm sorry, that's for the star position. So you do that for the true star. If you want to do the mountain drop, you do 180 times the distance over 2 pi r, and then that gives you the amount that you subtract from the flat Earth prediction, and it comes out to be what the raw globe predicts. At like it's identical to what you predict using Jesse's method for converting the drop into an angle. So that works out, and then I have the formula for adding, what is it? It's basically converting 7/6 r into uh, degrees per minute. So instead of getting 217 for the raw globe, based on the distance, they get 219. But again, that analysis is entirely separate and irrelevant because the refraction between us and the mountain doesn't matter. But I do have it included so we can see how it affects the measurements. And then I have uh, two spherical trig ones that derive a chord length and a great circle distance. And I also have one that compares the refracted position from stellarium. So no matter what um, because nobody could agree on a refraction formula and all that shit, I just subtract where the positions were in stellarium, so I know exactly how much refraction there was between the those locations, and then I add that to uh, I just have the exact amount of where it was in stellarium at the time, so I have one to compare that to. And then yeah,
So
and then so I backwards derive, or I say backwards a lot, but it's just deriving it. I derive the elevation of the mountain peaks based off of those values and distances back to the observer, and I'm working on the comparison output for all of that now, so we can see what the relative figures are for that, because I've added so much stuff since I need to like redo the analysis section so that it's more clear and easy to read. So that's what I'm working on now. Once I get that, I'll redo all the other sheets because I just got to copy in the information there, and then it'll all be nice and presentable, hopefully, and we'll have the exact comparisons for everyone's method consolidated into a single spreadsheet so that everybody is represented. And if anyone has any globular things they would like me to add, like I said, if it's relevant to the thing, I'll definitely add it. But I think I've added in Steelman to quite adequately because I've gone outside of with the scope of our analysis using true positions and to incorporate to see what their exact differences is and see what their gripes are about.
So, all right. Well, I can tell you this. Looking at the spreadsheets early on, um, I I'll be honest with you. I struggled to keep up when you guys. I mean, you're sitting there explaining them and pointing them out, and I struggled. But that what you did, it just seemed like it was so easy for me to just read, and I'm somebody that's I'm the normie here, reading them spreadsheets, and I
Same.
really felt like I understand. So I like what you're doing. Don't change that. That's a good thing you're doing because it makes it easy for me to understand.
Nice.
What is um so like when you know I hear okay, our angle from Heffron's house to Pikes Peak was 2 degrees 31 minutes, and when we go to Stellarium, uh, we get the unrefracted uh, true position of 2 degrees 31 minutes. What is the refracted position?
The peak
Yeah, no,
240
for the star.
where?
When you go to Stellarium and you want to know the actual position of the star, you turn off refraction.
Yeah.
If you turn on refraction, what does it say?
Are you talking about for the observer location or peak?
for the peak.
For the peak, it is at 232. It's actually a little higher than what we predicted for our occlusion. The data set for Pike's Peak, they come in about 232, I think, is the lowest one, maybe 231, but they're all about 232 to 234.
Okay, but wouldn't that mean that we'd see it longer if it was up that high?
No, we would see it get occluded sooner because it's getting hit by an object that's higher in elevation. We would see
Okay.
it for less time.
All right. Well, I'm, I was looking at what does celestial refraction do, and it's saying that it makes it look higher than it actually is.
Oh yeah.
And
So
then
at the peak there, they predict 246 with refraction on. Pretty sure that's their value. 248, yeah.
that's so how does that work? Because they're saying it's being refracted up over the stars actually lower. I mean, that part I'm not getting exactly
Oh yeah, I should
because
do a comparison on that too, because that's the inverse of the occlusion, right? Or I mean,
yeah.
emergence. Yeah.
And I mean, if it was working like they were saying, oh, it's just it's refracted up over the mountain, then it seems like the occlusion time would be later, unless occluding the star occludes, whatever this refracted amount's supposed to be. If it's supposed to be up higher, then we should see it longer, shouldn't we? But it's coming out 231, but it's saying
Oh
248.
yeah, no. I see what you're saying. Yes, that proves the method that when the true position intersects, it's game over. That's yeah. That's the opposite of the emergence one, because it was easier, like it was real clear to understand that relationship with the one where it was emerging, because it predicts that it's already higher, but for some reason you can't see it until it intersects with the true position, which is you know
So
hilarious.
basically, some of the stuff that they're doing, trying to force their position to get a better standing, is actually improving what we're doing, or what you're doing, I should say.
Well, the celestial theodolite method itself, revealed the how what they're doing, like how much of a fudge factor they're fudging to make the globe.
Well, we got the big dogs yapping. You got Mordwan jumping in. You got
Nice.
Ruhif. So if they're the ones barking, then there's got to be something to it.
Sounds to me like basically what this observation did was it proved that the sky is over a flat plane, and what we observe in the sky is the graticule of the dome of our vision over a flat plane. It just reinforced it.
How dare you make that meaningful comparison?
I believe there's some comparison to that in the relativity too. But we do have a couple hands up. You still there, Huff?
Yeah, I'm still here. A little bit of background on my question. Unless Round wants to talk about the celestial theodolite, because I'm going to go back to a previous conversation.
Yeah, I just had a couple of questions. Thank you for that. I'll start off by saying I don't know any of your maths and stuff, so I'm not questioning you at all. I haven't looked properly into it. I've seen the picture that you put on there. I think I understand the concept of what you're achieving here, but I could be mistaken, so I'm not questioning. The only question I have is, these are about predictions, right? Predictions of what time the star will disappear behind a mountain. I know
No.
that. No, is that not what it's about? Okay. Well, you don't
Or
have to
maybe
answer
I'm
it now.
missing maybe I missed what Alan was saying. But the Steelman is that they watched the star disappear. They took a timestamp of that star, and then they extended the view by putting themselves on the mountain where the star disappeared. and made another look at that star, and that star, when they turned off refraction, it put the star in the exact location of the time of when the star disappeared behind the mountain, which basically it should have been lower in the field of view because the star was supposedly being refracted up over the curvature of the Earth.
All right, some of that is what we do.
Sorry, Alan.
You're good. So, what we do round is we know the mountain peak distance, right? And we know our location. So we can make some predictions based off of what the elevation would be if the Earth is flat. Because if the Earth is flat, then there's going to be no drop over distance to lower that elevation. It's just going to be whatever the distance times the tangent of the elevation is. And that's going to give us the angle for like whatever the raw flat Earth angle would be. And then when you do the when you subtract globe drop from that, the raw globe drop, you have, what you have the angle for what the globe would predict. And because time equals angles using stellarium and celestial navigation and all the components that quote unquote make up the globe, angles equal time. So what we do is we observe stars. We take our filming equipment and we just look at stars. We look at the mountain peak at night and we just record. And because we know what time we started our recording, we know when that star is visible, when we can see it, and we see it coming down towards that mountain peak, and then we don't see it anymore. And we just we pause our video and we look at what time it is when it was no longer visible, and then we go into stellarium and we reference we reference the position of the mountain peak, and we enter the star there, and we see where its true position is at that time, and if it's closer to the angle that the globe would predict, or if it's closer to the angle that the flat Earth predicts. So like that's like step one of the analysis and method of how the occlusion timings work for the quote unquote prediction of it.
Okay. So I think I understood you there. First question would be, if you're talking about drop of the peak due to curvature, why are you bothering with the star? Okay, is the peak lower than what a flat Earth would have it?
Yes. Yeah. If the Earth is a globe, then it's going to be lower. So, for example, if the peak is 50,000 meters away, and there's an elevation difference between us and the peak where it makes the elevation of the mountain 227 meters relative to us, we get a specific angle for that. And if the Earth is a globe, then there's going to be 200 meters of drop between us. If you convert that to an angle, you get 11 arc minutes. If you subtract 11 arc minutes from our 231 raw trig angle, you get 217. So the raw globe predicts that mountain's going to be lower at 217 degrees. And the reason sorry, go ahead.
No, I think you were just about to say what my next question was. So why bother measuring the star? If you can measure the mountain and see that yes, it's lower than what the flat Earth says it should be.
Yes. So occlusions are a physical process, and what I mean by that is once an object is below the physical object that's blocking it, there's a point where it can't be refracted over anymore, and the observer is no longer going to see it. So like, I'm not saying that refraction doesn't exist, because what happens is refraction between the object and and like the peak, for example, will cause the object to be able to get lower before it's physically not visible anymore for an observer on the other side. But it can't be to the amount where the object is like, 20, 30 arc minutes below it, and somehow it's like still also above it. You know what I mean? Like there's a cutoff point there. So with that said, we know that when the star isn't visible anymore, it definitely got blocked by a mountain peak. Like it's no longer visible. So then we just go, okay, where were you at that time, star? with respect to the mountain peak.
Does that make sense, Brown?
The whole process makes sense. I don't really see how you're going to get a more accurate by adding another layer to it that includes refraction, which is kind of, a mystical number. You can't really put your finger on it at any one time. I don't see how you're going to get a more accurate result than just measuring the peak.
Well,
Okay,
if
but
you
that's
extend the
just
line
me.
even longer, right?
Well, interestingly enough, what we can do, we can use the occlusion angle using the true position of the star. So like whatever that angle was with respect to the mountain peak, we can reference that angle and we can derive what the distance is based off of the elevation of the mountain. And we can do the same for the globe comparison, and we could see who gets the closest approximate distance. Because in that part of the comparison, and then also we can also do the same with the distance and the occlusion angle to get the elevation of the mountain, so we can compare who can derive the closest approximation based for the physicality of that peak for what it actually is based off of the occlusion timing. And so like the distinction there is the triangle that flat earth creates with the true position shows that the only way that would work is if the sky is parallel with the ground and it's not curving. That would be the only way our triangle works, and that's what it is being shown with the occlusion timings.
Okay, so what kind of difference are we talking here? I know it's hard to maybe quantify without actually just using the degrees difference. What are we talking, 219 to 221 or something? Or what sort of difference are we talking?
Okay, so optically, we'll do Pike's Peak, for example. So for Pike's Peak, Flat Earth predicts raw 231 degrees. For the globe, they predict 219, and where the star actually was when it was occluded was 222. And for the and then there's also the raw globe that predicts 217. So when we make all the comparisons, I don't have the 217 comparison. Actually, no, I don't have the 217 comparison yet. I was in the middle of doing the refracted position. But so going off the refracted positions, for example, to give you an example of what the data looks like for Pike's Peak, where it's not close, Flat Earth is off by, when we derive the elevations and the distances back to where they actually were, we're off by 36 meters in elevation, because the star was occluded at 233. So it was way higher than it was even higher than what we predicted by a little bit. So anyway, we're off by 36 meters in elevation. Globe Earth was off by 125 meters, and raw globe was off by 200 meters for the 217. It isn't here. And then for distance wise, Flat Earth was off by 800 meters. Globe Earth was off by, Stellarium Globe Earth position was off by 3,000 meters, and raw globe was off by 5,000 meters. And then to give you one where it was closer to globe, we can do this Blend Mountain one here. So we have a flat Earth do you have any questions so far about that one, or?
No, I think you've explained it well. I think I feel like I understand it.
Awesome.
Yeah. So, yeah, reasonable sort of assumptions. Sorry, not assumptions. Reasonable sort of stuff that you've come to. I'm glad that I asked, because I feel like I understand it now. Thank you.
Yeah. Let me go over the globe one real quick so we can see the difference too there. So we got one for the globe where the distance between observer and peak is 40,000 meters. The peak elevation is 635 meters. The observer elevation is 4 meters. So there's 629 meters for the peak elevation between us for the delta altitude. And then the elevation for flat Earth prediction is 53 arc minutes. The raw globe is 41 arc minutes, and the the time in stellarium in which it was occluded at for the apparent position at the observer location was 42 arc minutes. And then so when we compare who was closest on that, let's see, the Flat Earth was off by 172 meters. Globe Earth got 121 meters, so you guys were like a little closer. And then Raw Globe is off by 400 meters. And then for distance, Flat Earth is off by 1,500 meters. Globe or Flat Earth is off by 15,000 meters. And for Globe Earth, they're off by 9,000 meters. And for Raw Globe, they're off by 91,000 meters. So it's like, that's why they don't want to do the comparison where with Raw Globe or anything like that, because it's like, it's preposterously off. Like, it's just when you get into it. But the refracted one, it gives it like the illusion that it's close, right? Like, I wouldn't consider that a super win for either one, because at the same place there's or actually that was a different same place, different distance. The expected drop was 38 meters, and then we're off by, or we predict 81 meters in difference, and the Globe Earth predicts 26 meters. Sky moves at 30 meters a second. I mean, these ones are so close where it's like, tomato potato, but it's not so far off where it's like, oh, the globe clearly won, because when we look at Raw Globe, it's super off and nobody wants to talk about it. So,
Well, there's no such thing as Raw Globe, though, really, is it? There's always atmosphere.
No, there is in this analysis, because the refraction between me and the mountain peak isn't going to affect the occlusion timing, because the intersection happens on the other side of the mountain peak. So all the refraction conditions that matter are going to be on the other side of the peak. So when we no longer see the star, there's no refraction condition between us and the mountain peak that could possibly help lift the starlight that isn't there anymore. Pretty ingenious, right?
No, that's not right.
It absolutely is.
It's refracted. Okay, look, maybe I'm wrong. Maybe I haven't thought about it properly. But if it's refracted, it's going to be lifted up.
No, I 100% agree. But the time, right? The time, because we don't care how, because our device that we're looking at recording with doesn't have a way to measure angles. All we know is that this star was not visible at this time, because time equals angles in stellarium and the globe, and the celestial navigation and all that's all based on relating angles to time. So when we have a time, we have our angle. We don't know the angle beforehand or anything like that. Like, we're not measuring it optically. So if it's up or down in elevation, it doesn't matter at all. We only care the time that it's not visible. And that's how we eliminate the refraction between us and the peak. That's why we don't consider it in our analysis. And that's why there's a distinction between you're not part of this, right? But I'm just putting this out there for everyone that's been following along. There's a distinction between the analysis that Heffron is doing and what other globularist proponents have been doing. And they've been saying that they're analyzing the quote unquote Heffron method, but they're not doing that at all, because we're going raw for raw, because the understanding of the occlusion method and there's no amount of terrestrial refraction that could help, because the occlusion happened on one side, on the other side of the mountain, so hope that helps, maybe to help put it in perspective.
Maybe I'm misunderstanding, but I would have thought refraction would alter the time, because you record right when the star disappears, right? That's your occlusion time, right?
Yeah, it does, but refraction can only alter it on the other side of the mountain. So when it's not visible,
but it's going to change when it disappears.
It might do that. It might do that optically, but the time is what is important, because the time it corresponds to an angle.
But the time that it disappears is going to change based on the amount of refraction.
It may, and that's why it already compensates for it. That's the purpose of it. Because that's what I was going over in the analysis, where I was looking at the difference in angular position between the true position of the star and the refracted position at the observer location. You can see where there's like a reasonable intersection point where, okay, there's like a 4 arc minute difference where this star's true position, like it's so-called light source, was 4 arc minutes below this object, or in difference from it, and then it was no longer visible for the observer. So like we have instances where that timing based on the difference makes complete sense and corresponds to when it was no longer visible. So the methodology is sound, and there's no like the refraction between us doesn't change that, because everything was done on the other side of the mountain. It's quite a precarious predicament, because if you think about it, right, if it's already refracted and then it's not visible, there's nothing in between you and the star that could bring it back. So the fact that anything may or may not be lifted between you and the mountain peak isn't bringing the star back or changing the time. The time already happened when it's not visible.
But the time that it became not visible is what you're recording to get your angle. So if it disappeared 2 seconds later, you're going to end up with a different angle. Am I understanding that correctly?
Yes, and specifically, we look for instances in measurement where the difference in angle is significant and not equal to the same position, so that we can actually tell the difference. That's specifically the point, because there will be a little bit of refraction, right? But that's still gonna correspond to a different time that's gonna be closer to the globe versus closer to flat Earth. It's only when they're close together, where it gets indistinguishable.
Right. So again, I feel like I might be missing something, because I'm not really understanding why this is such a, I don't know, for want of a better phrase, globe killer, when there's really not a huge difference in both measurements.
Let me try.
Well, hold on one second. So I thought the same thing too, Roundhound, when I looked at Pikes Peak, because the difference in raw globe versus refracted globe versus the actual angle of occlusion isn't that much. Raw globe's 217, refracted globe is 219, or refracted terrestrial globe is 219, and so the actual position the star wasn't visible with just celestial refraction was 222. So in that measurement, it doesn't affect it that much, but that's because the refraction angle is, when you ratio that against the distance, that's what determines like how impactful it actually was. And in these scenarios, you can see where the refraction lift will either be like equal to the drop, or twice the drop, or even 3 times the drop in certain scenarios. So it is significant. It doesn't look it's relative to the measurement, because it's a ratio of a triangle. So when the variables change, the amount that it impacts it is actually significant.
Okay, I'll take your word for it for now.
I do have a spreadsheet, my lord. It's posted in the thing. I'll put it up in the jumbo, so you can check it out sometime. And then we've got some videos on the celestial theodolite process if you want to check it out.
I think I did post your the spreadsheet up there.
Oh, nice, perfect.
Oh. Earlier, somebody was saying that perhaps somebody should be on the mountain peak as well.
Well, that wouldn't really change anything because for our position, we're referencing the true position, which is a calculated position based on where the star once was on the first cusp of Aries and then adding 15 degrees per hour to it. So you're not gonna optically see that. And then in addition to that, you would still see the apparent position of the star. So that's whatever. Stellarium says that it would be at 246. I don't dispute that. That's totally fine. That's not an issue at all. But like it would be kind of cool, I guess, to like see it, but it wouldn't like it's not gonna change anything, you know what I mean?
Yeah, that's what I thought too. I didn't see how it'd be relevant, but apparently there's some flat earthers that would like to see that.
It would be bonus supplementary, but it wouldn't add anything of value to the analysis because we both predict the star is gonna be optically in a different
Yeah.
spot. So it would just be like you would just be like looking at a side by side of it, and then you would see one not there, and then you would still see one there. you know, that's that's it. It would be cool though to see it.
Yeah, I said I didn't see how it would change anything either.
I think it's because every time anything gets done, like the globe lads are like, "Oh, dude, you didn't film it from a helicopter upside down using a 360 camera." Like, nah, I didn't do that, dude. Sorry.
Well, especially seeing
well, there's your problem.
what's that?
Yeah. He said, "Well, there's your problem."
Yeah, we didn't do it upside down with our heads between our legs.
All right, can I bait you a little bit? Any one of you?
Go for it, man.
So why can't I see the Eiffel Tower from China?
multiple reasons. Contrast reduction would be one of them. Just assuming flat Earth, perfect optical conditions. There's a point in which the things in the horizon will become indistinguishable from the opacity, like just due to the opacity of air. So everything's going to be white. So so if you were on the ground at sea level looking out at the ocean trying to look at China or whatever, or the Eiffel Tower, the blue ocean would eventually turn into the white sky, and the white sky would just be indistinguishable at about 330 kilometers. I can link you to all the math on that.
What's that actually?
If you want, it's called.
Isn't there a name?
Yeah. Sure. So then I was going to ask. So then, why do flat earthers ask for a picture of a ship upside down Australia from a satellite?
Because that would be a thing, I think, wouldn't it? Couldn't you have a satellite upside
You'd be
down
looking-
relative to the ball? Upside down?
You'd be looking through the same amount of atmosphere. Like, have we ever seen a ship in America up the right way from a satellite? You'd be looking through maximum amount of atmosphere.
Yeah. You know what though? I asked somebody one time for a airplane upside down, and he goes, "Oh, I'll give you one, but you're not gonna like it." And I was like, "What? For real?" And he linked me. I wish I could find it. He linked me some fucking article, man, and it had like this fucking Sega Genesis JPEG picture. You couldn't even tell what the fuck it was, and he was like, that's your." So like, I never asked again, but yeah, I don't know nothing about asking about satellites upside down pictures and shit. I haven't done that one in years. That's a classic, bro. That's a throwback.
Upside down satellites. Huh? It's amazing that
ships.
I mean, they're like what, 250 miles up there. All right, you just see them. All right. I mean, one's the size of a jumbo jet, and at 6 miles, that sucker's hard to see. I don't think you're looking at satellites in space, bro.
What about the ones that aren't on balloons? How are they staying up there?
Kind of real low. I can't hear you.
The ones that aren't on balloons, where you can't see the balloon. How are they staying up there?
Must be in space, bro. I don't know.
What?
I got a question
Well,
for you, Roundhound.
okay, go shoot.
With all the satellites that are in space that do take pictures of other objects in space, how come no satellite has ever taken a picture of another satellite?
Oh, dude, imagine someone's spy satellite was spying on their spy satellite. They're just up in space watching each other like every
Like
time they
you see
pass
the
in
camera,
orbit, they're just like mean mugging each other.
you see the
That's what they
camera
all are.
looking somewhere, and then another satellite like comes into view, like
That's what they all
bombing
are.
the picture, photo bombing.
That's what they all are. There's only one real satellite. All the other ones are spies, spying on the spy one, spying on the spy one. There's 9,999 spy satellites and one real one.
Oh, that would be
Yeah.
epic though. It'd be like cheaters for space. Like, bro, I see you. This is what he was doing when you weren't looking. Let's reveal.
But to answer your question, there are photos of other satellites from satellites.
How dare you?
Oh no, don't you hate it when evidence is presented that just
I
totally
think
squashes the same?
there was some raw images from Discover that I Can Science That and I went over once, and I'm pretty sure in one of them there was some space debris. And I think his explanation for it was that there was like these weird artifacts in the images, and his explanation was for it that they were satellites or space debris. So is that what you mean when you said other things or whatever, or is there like actual canonized ones of it?
Yeah. There's blatant photos of other satellites.
Man, they say they got satellites 22,240 miles above sea level.
Yeah, is it the Himawari 8? Takes a photo of Earth every 10 minutes, and you can intercept the photo before it goes to NASA, which it doesn't even go to NASA. It goes to the Japanese version of NASA, or Japanese meteorology place. But you can intercept that photograph as it's transmitted yourself and get your hands on that photo before anyone else gets it.
Well, that's not every 10 minutes. It's never been 10 minutes. It's always like 30, 40 minutes. And then on top of that, you where do you go? Can you send me all the stuff to get the raw stuff? Because when I went to go get the quote unquote highest level of raw publicly available data with I Can Science That, the data that we got was already sanitized and had been precompiled as well at least once.
And here's what I got a problem with that. The Van Allen belts start about 600 miles away from Earth, and they go out for 36,000 miles. So these satellites are right inside of the Van Allen belts.
Didn't Jeranism find? Sorry, am I interrupting somebody?
Nope.
Didn't Jeranism find like the backdoor folder for where they store all their data for all future images of the Himawari 8?
I did hear something that before he turned all globy, that he had debunked the Himawari thing of some sort. I have not found the video in which he did that, though. It's on his Jeranism, I believe, but I haven't seen it. Yeah, satellites right there in the middle of the Van Allen belts, man. It's crazy, right? Those bad boys go from about 3,800 degrees to 35,000 degrees. Tough satellites.
Yeah, well, if you used a celeste or a space, what are those things called? A space sextant. If you use a space sextant and you fly a really straight line, you can make it through the Van Allen radiation belt.
You need a plumb bob.
Bullshit. They were playing Frogger, bro. They made it through one time because they played Frogger and it worked.
They ain't know about it.
Hey, all you gotta do is just keep holding forward and see what happens.
Yeah, all that left right shit's for, I don't know, people who play Powerball. Full speed ahead, bro.
But yeah, your low Earth orbit ones there are anywhere from 250 to 500 miles. And I just don't think you're going to be able to see the size of a satellite 250 miles, man. Especially going 17,500 miles an hour. Think you're being gassed there. What's that, Alan?
Is that Man of Stone I see in the audience? Or
It is Man of
in the
Stone.
panel, I mean?
Well, hey.
What up,
How's
Stone?
everybody doing on the Friday night?
Chilling.
What's going on,
So,
Stone?
just wondering why we ain't playing code names right now, my boy.
Yeah, just biding my time. That's what I'm doing. Well, it's been a very interesting week. I'd say the high point was Sunday when we got down and dirty on Glowbusters with the old shadow sets spiel.
You know, that was actually a pretty good little presentation. I didn't catch every single aspect of what you're going with it, but when you recapped it again,
You didn't catch it as in didn't quite comprehend it, or didn't wasn't
well, I
watching it
mean,
entirely?
I did comprehend it. You did say some things that I got to rewatch it and kind of go over again. But no, when who was it Casey or something like that? She said what?
It was
And then
Cammy or Karen?
Karen, there you go. Not Karen, the other one that was in there.
Cammy Nodell.
Yeah. When she said that, I don't get it, and then you went over again. I was like, yeah, I wasn't getting it either. But then you went over it again, and I was like, oh, yeah, it was pretty good. I liked it.
Well, that's good. I'm glad I turned your light on, man. That's what it's about. That's why we spend the time. No, it's good to review all flat Earth debate argument points just to up your general fluency. I think as general practice. So I don't think it's at all redundant that I got this up on BitChute. We went over to the clubhouse and did the dance, and now we're doing it for the Glowbusters crowd. I think you're right. It does come out a little clearer, and we discuss certain tertiary aspects of it each time in at different places along the line. That worked out pretty well, I think. I don't know. It was kind of entertaining at the end when Karen was throwing up a few objections, refutations. For me, that was some pretty good exercise, I think, and I guess it helps to reaffirm confidence in the concept in general, because there's somebody there who's totally prepared to tear it apart if it's possible to do so. You know what I mean? And in this case, it turned out not very doable, not very tear apartable, if you know what I mean. That there were some things about what she was objecting to where she was doing a fair bit of comparison of apples to oranges, if you know what I mean. That when at the end of my video that's up on BitChute, the first time around to present the data, I showed footage from a piece of video by Dave Weiss, and all it shows is the sun, fully visible, fully round, and a fair bit above the horizon, slightly staining, blotting out some of the cloud deck, slightly below it. And it's footage that he took during the winter up on a hill with a drone that he sent up another 100 feet above his head so he could get even higher in terms of his vantage point to catch the sun on a fairly clear day all around, where the sun actually doesn't set per se like the globe model. It physically fades out, and it fades out as a fully formed disk. Whether it's vertically compressed a little bit because of refraction, blah, 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 that's immaterial to the observation, I think. It's all about the opacity value of air and how eventually, as the sun moves farther and farther away, the sun loses the ability to penetrate all of that air on a strictly horizontal angle of view from the observer's point, if you know what I mean. That there's just so much air there. And it's, I think also it was a possible observation because he was viewing the sun over land instead of over the water at the beach, like Karen was talking about what she had observed countless times, blah blah blah, on video or however she wants to talk about it. There were so many parameters that were just factors, even that were completely different. Her experience to Dave's video, and it was kind of weird that she couldn't really pick up on the differences that I was pointing out. I'm not sure why the conversation went in that direction, but still, it was. Overall, I think it was pretty good exercise, just to even for the sake of the crowd who are listening, to hear the exchange and judge those points for themselves too. You know what I mean? Pretty cool.
Yeah, it was a nice back and forth seas to get some stuff hammered out. And one of the things that helps me learn things best is when argue like an argument is able to be argued to completion, and you could hear, because like sometimes you might not know what questions to ask or whatever. So like when you hear something being argued out with people, it's super beneficial to for clarification for me. So it's very educational.
Yeah, it's good stuff. Good to play the hits.
Yeah,
Hey,
dude,
Alan, what
I can't
what
wait to.
what are we doing this Sunday is the question.
Oh, dude, this Sunday is going to be the Celestial Theodolite update for me. I'm going to
Okay.
do that. And then, also next Saturday, there's going to be a little trivia hosted by Andrew. Well, it's going to be
Andrew, is he
hosted.
finally doing it? I've
Yeah.
been looking for that. I'm waiting to see it on the events calendar, but it's just not there.
Yeah. So that
Very
was my
curious about
bad.
that.
That was my bad.
Okay.
I got locked up in spreadsheet land. So, but anyway,
You sure did.
next Saturday at 11 p.m. Eastern, we're going to have a trivia night where you can win some Aether Cosmology merch. So if you want to participate, you come in the Discord and play. And then we'll probably do something for the YouTube chatters out there. If you're hanging out in the YouTube chat, we'll do something for you guys too midway through or something. But yeah, if you want to participate and win some Aether Cos merch, we have t-shirts and hats. Saturday, 8 p.m. or I'm sorry, 11 p.m. Eastern will be trivia night, and link to the Discord is on my YouTube. So if you can go to any YouTube video, look in the description, you'll find the Discord link there.
Cool. I definitely look forward to winning some of that stuff and receiving it by sometime in January.
Nice.
If all goes well.
I'm gonna get me one of those hats, man. I'm stoked. Actually, I got into Stones trivia one time, and I don't know if that was the last time you did it or not, but I had a blast. It's gonna be a good time.
Cool.
I know a guy that'll get you a hat. I can put in a good word for a little hat situation for you.
You know a guy?
Hell yeah, you know a guy. Dude, you know what?
I know a guy who knows a cat.
Knows a cat. I got a picture up in the Jumbo Allen. Were you wandering around on one of my job sites, dude? I big ass bear paw prints right at the foot of the crane.
Yes.
I was like, what the fuck is this? Yeah, it's Alan. What's up, bro? It's been a while.
What's up, man? I saw you in the YouTubes the other day, I think. I was like, where's my boy been?
It's bridge season, man. I've been so damn busy and then juggling that and the kids on the weekends and stuff. It just IRL stuff being what it is, man, but I'm trying to be around. I didn't go anywhere. I've been fucking swamped.
You were doing real life adult stuff? Gross.
Right.
You're telling me, dude, it is gross. My oldest just turned 15. Now he's driving and shit. And he's all like gung ho to be an adult. I want to backhand him. I'm like, dude, pump the brakes, bro.
It's like, slow it
you're gonna
down,
have to-
lad. What are you
You're
doing?
gonna have to do that for the rest of your life, and you're not gonna want to anymore. So like, just enjoy this while you got it, buddy.
You should say, bro, you're not paying any bills, man. Relax, enjoy it, because pretty soon that shit's gonna end.
Hey, so did anybody cover yet what happened last night regarding the $10,000 challenge?
What happened?
Oh, dude.
What?
I'll take that as a no.
When did this?
Oh.
Well, Alan and Shane like to get over to Lamer or Clubhouse and get down with the boys and girls and give them a selfie update now and again. And that happened last night.
Dude, I was there. I
And,
didn't hear no challenge.
Our intrepid coffee showed up about 2 hours into the process with his full slate of third-party acquired questions. And it's really unfortunate that the person writing his questions couldn't show up to ask them, because that person probably has even the slightest grasp of what is actually going on during that observation, that process, that method that Alan and Shane have been dutifully recounting for months to this crowd over and over and over every week. Yet Coffee is there asking unintelligible questions that really do nothing more than indicate how he does not grasp what is going on. And it's ironic because he keeps responding with, yeah, I get that, but what about this question? And he asks a question that tells you he doesn't get that.
Dude,
And
he was doing that a lot.
Alan said that maybe 3 times, something around 2/3 of the way through their discussion. And then Austin chimed in because he keyed in to what's going on here. And so Austin said something about, well, actually, he challenged his nomenclature, because Coffee has a rather weird complex. It's desperation based, where he strives so hard to convince people that he is more educated than he actually is, and he uses advanced words, vocabulary, with reckless abandon, and absolutely no idea if he's using the correct word or not. And one of them happened right in the middle there, just before Austin jumped in. It was about how Alan was bringing up a reason why his question was incorrectly worded, or frankly doesn't address the issue, or fails to actually recognize the part of the process Alan has been outlining to Coffee as to why that question is inappropriate, and this is instead what he should be focusing on. Coffee's response was, yeah, my man, but that's not prevalent. You feel me? And the word is relevant, not prevalent. So I kind of interrupted with that one and corrected him on it spontaneously. And a little more time went by, and Austin was just revving. I could hear it without him even pushing a button. And eventually he came on and said, okay, he challenged Coffee on his use of the word arbitrary, when the parameter he was describing was fully voluntarily chosen specifically, not arbitrary at all. In fact, it was an independent or dependent, whichever I forget, variable of the experiment, of the observation. It was something where, it's got to be like this in order to produce that. It is the exact opposite of arbitrary. And then again, Coffee started to slam his foot down and tell everybody that he knows what he's talking about. Austin was having none of this and challenged him immediately, saying, okay, then steel man Alan's position. Coffee immediately started to object to the proposition, frankly, and Whitsett cut him off immediately, mid-sentence, saying, hey, I will give you 10 grand if you can steel man Alan's position, which Coffee promptly failed to do, offering only the comment, why would I steel man his position when I know he's wrong?
Unlucky.
It was just a stunning display of pretentious ignorance. And I have noticed it to be a predominant part of coffee's style for months. And of course, I notice it because he has challenged myself, on several issues. Climate symmetry between north and south was one of them, on and on and on. And it's really interesting listening to Coffee come back into a room a day or two after he was speaking to Kat about a particular aspect of self-theo, where again he was asking the inappropriate question and not really and actually demonstrating he does not understand the question he's even asking. And Kat corrected him on it in detail for several minutes. And he went away and thought about it and actually came back. Now, this is where I give Coffee points. In this one instance where he said, okay, Kat, you're right. I was not understanding that part of the situation. It doesn't mean you're totally right and everything else, but at least tell Alan and Shane I apologize because of this particular question, because of this particular point. Now, I give him that. But unfortunately, Coffee has a mental reset button, so it would appear, that, I don't know, maybe around dawn the following morning, something happens inside his psyche where a big giant thumb comes down out of space and pushes his reset button, where he doesn't remember that any of that stuff that took place the night before. It's like it never happened. And he cruised right on in last night after those 2 nights. So this is night 3 last night, and runs through the same rigmarole as if it had never happened. It's stunning to watch. I wouldn't invite anybody to come and waste their time to watch it, because really we only live so long. You're not really going to get anything out of this to watch it again. I'm sorry, I don't recommend it, but truly it was quite the anomaly. I was a little stunned, but I was just checking if you guys had covered all that. It was some pretty cool current events.
So, can I ask you a question, Stone? Are
Yeah,
you
shoot,
sure
man.
this analysis doesn't come from the fact that he's packed you up already?
Oh, that he's cooked me? I feel the urge
Dude, that was
to
funny, dude. That was
I
funny.
feel the urge to respond doing an impression of Bruce McGuire. I mean, I've never seen such sartanian levels of gophery. I mean, I just feel the need to go in that direction, but I won't, out of personal dignity. Not. But yeah, good question, Ken. Good question.
Yeah, I about fell out when I heard him say, I already packed you up. I was like, what?
Yeah, that was entertaining, wasn't it? Ah, sweet denial.
Stone,
Holy shit. That's like the flurf herder saying he's herded a flurf once. One flurf ever.
When was the last
Or,
time?
when Sydney and Peter come in and just do what they do on repeat every Friday.
Stone, when's the last time you had to make a mathematical correction because you were just like, oops, you forgot to account for the globe, and there it was. Like, oops, I messed up my Newtonian dynamics. That it turns out the vector math does work out. When's the last time you fucked one of those up?
I better check my logs and check when that actually happened. Yeah, right.
Dude, that Newton one, dog. I can't wait to go over that one again. That's gonna be a doozy. Newtonian dynamics is my favorite. Yeah.
The one where we add the vectors and get the fucking truth in full graphic detail.
Yeah.
Nice bong hit there, Alan. That was awesome.
I don't know what you're talking about. There's nothing like a free body diagram, though. I love it.
The sounds you hear are not the sounds you hear.
That was a fun video. I got to admit that. It was great to make that thing. So much fun.
Oh my God, I got so much catching up to do, dude. I can't wait. I got so much catching up to do. I'm over here like, what the fuck are they talking about? That's how out of the loop I've been.
Well, sometimes it's good because then you can see things as a little fresher. That's cool enough.
Right. What's up, Huff?
Goodness freaking gracious. I swear Twitter's gonna anyway, sorry. So a
Don't
little
get
bit
me
of
started
a
about Elon.
I know, but all right. So a little bit of background for those of you guys that weren't here. Zinni was in here talking his, whatever, and we got onto Canagoo, and I made mention that a silhouette can't refract, and then he posted a thing that says he posted a picture proving that quote shadows can refract, and I'm looking at it and I'm trying to see his argument here. The only thing that I could think of is that he's talking about the shadow on the water above the diver being distorted by the surface area of the water. Does anybody know what he's trying to say? Because I just want to freaking anyway. Zinni
You want to
Yeah,
is
yeah,
slap
getting
I
on
him
my
can
and
hear
nerve,
stuff.
but
you.
anyway,
I get that.
I am super confused. I'm just like, what the f?
Okay.
Yeah, it's just
Did I
Sydney.
did I hear you correctly that he was trying to compare it to some picture or video taken of somebody diving?
Yeah, pretty much.
So the
Okay,
distance
so
between the
so
diver
the
and the
photo,
observer was how much?
I don't know. The
Give or
photo that
take.
he posted is yeah. The photo that he posted is a picture that looks to be only about 20 feet away of a diver's silhouette in perfectly clear water with the reflection of the diver in the water above being distorted by the waves of the water. And I am trying for the life of me to figure out what his point is. And I'm not getting it.
I love it when Gloobies bring oranges to an apple competition. It's always entertaining when they
I
hold up something completely irrelevant, meaningless, and frankly is several orders of magnitude out of where we're actually looking at things 100 or so miles away. You know, I've been listening to this shadows don't refract argument for a long time, and I have said nothing about it. And while you were just describing it, there's one part about that um, of the geometry that is occurring to me, and I hand part of the assertion to the Globies in saying that anything that you see that is 100 miles away, the light coming to you from it, or lack of light, therefore, coming to you from it, can be distorted by the atmosphere in between, especially if it's a horizontal observation, especially if it's over the water, et cetera, et cetera, et cetera, right? Especially if it's not winter, it's there's a much bigger lapse rate. You know what I'm saying? The factors that affect it, everything that Rayleigh talked about, mixed in, that it's not going to help you see the shadow more clearly. No, not at all. It's distortion. All of it is, and all of them are forms of visual distortion and are going to reduce clarity of the image or the shadow of the image, et cetera, et cetera, et cetera. But the one thing that occurred to me here is all about the angle of incidence here. You know, when we look at the cool glib textbook graphics of the explanation of refraction, one medium to the next, it's always a really thin medium going to a really thick medium at about a 45-degree angle, and none of that shit has anything to do with what we're talking about here. But they seem to want to apply it. Look, if the shadow begins at the peak of the mountain 114 miles away and then comes down towards the ground, yes, in front of you, yes, in between you and the mountain, but hits the ground still fairly close to the mountain, not you, then the shadow itself, yes, is also far away and is also much closer to sea level, is more susceptible to those factors I just listed off that would cause it to distort, refract, not necessarily change its position in a big way up or down or any some stupid shit like that. Because when you look at the dip tables, you know what I mean? The dip charts about what kind of refraction is going to happen at 10, 20, 30, 40 miles. It's always expressed with a unit of measurement in the order of a handful of minutes arc. You know what I mean? Maybe 15 minutes of arc. That is a quarter of a single degree. It's insignificant. But yes, it is true that there is a bit of refraction because of the lapse rates involved in the air mass in between you and it. You know what I mean? But it is insignificant. So yeah, it's a factor, but how much of a factor is it is the question. And you guys, when you get into arguments like this, don't let it go. You've got to do the real digging. Get in there and quantify these values. You know what I mean? Get the real numbers. Work it out. Tell them what kind of refraction you should expect to see based on the textbook formulae, which they have no choice but to adhere to. It's the stuff they all learned in school and regurgitated for the sheepskin. You know what I mean? We all did that. They did that. We did that. Everybody did that. The textbooks are still out there. Thanks, Rockefeller. But we have a duty here. We are making a positive claim about something here. And our duty is to do precisely that. Get the goddamn figures. Don't give them any room to squirm, to make up bullshit. Don't do it. Don't waste your time even making the claim unless you have that in your back pocket, ready to whip it out and flatten them with it. This is, I mean, I'm going to toot my horn, go to BitChute, see the predominance of the 50, 60 videos that I've got up there, because that's my MO. I practice what I preach. Get the figures, take their formulae, work it out. Figure out what you should expect to see, and then match that up with the observation. That is what you use to clobber Sydney and all these other idiots with right over their fucking heads. Am I clear?
You could be the man I need to talk to then.
What was that, Round?
You could be the man I need to talk to.
Wow, you went choppy. Try me again. Third time's
Yeah, it's a lot of robot.
Yeah, I might just drop. Am I still stuff?
Well, that was clear. Just reiterate again. What did you say?
You might be the man I need to talk to. I was wondering if anyone would come up with real world numbers, not just the formula.
Okay, great. Are
real
you
world
on?
formula
Are you on
for
Telegram?
electrostatics to result in 9.8 meters per second?
Yep.
Per
Good
second.
shit. Are you on Telegram?
No, I'm not.
Okay, first big mistake. That's the first place to go because I spend my life on there. I run a couple of channels and I have a boatload of information, even far beyond what I put up on BitChute for you to digest, even before you get to asking me a question, because if you take it all in, I'm thinking most of your questions will be fully answered. So yeah, take the time, man. Telegram's free, and get yourself an account there. I am, of course, at Man of Stone, all one word, very easy to find. And if you want to make absolutely sure, check the bio. I mentioned that I'm ex-Vancouverite, ex of New Zealand, now in Uruguay. That's all mentioned in my bio, so you can make sure that you're talking to me. You clear?
Yeah, sure. You can't post it here.
I can't do what?
He was asking if you could
You
post
can't
it
just
on here for him so he could do it easily without clicking anything.
Oh,
I mean,
well,
I mean, without typing.
It would just make sense if you got evidence that supports a flat Earth. Why wouldn't you post it when most people
Evidence
do
that
it?
supports. Well,
Oh,
I've
dude.
got a buttload of stuff that I have indeed posted here. My Telegram address is in my bio here, so by all means, just right-click me, and again, your questions are answered. How am I doing?
Sure. Thanks.
So, what would you
All
say
right,
your
straighten up,
favorite
everybody.
proof is on your channel? Like, I think you know mine, but so like I'm not gonna say it and spoil it. But what is
My
your
favorite
favorite
proof on my
one
channel.
that you're just like rest in peace, Globe, dude. See ya.
Well, I really like Felix, and I like what I did with Einstein. I love the Moon Part 2, and I know you can't wait to do that on Globebusters, the recap of the figures there. R.I.P. Globe. I'd have to look at them all again to pick one, but those are the ones that hit me.
What's your Felix one? I'm not aware of any really good Felix analysis,
Oh.
or like I've seen some, but I don't remember anything
Okay.
significant from it. What's
Felix
the deal?
Baumgartner. Everybody knows him because he just died. He managed to land on a piece of pavement right next to a pool instead of actually landing in the pool to save his ass.
Oh, no way, for
Don't know how that
real?
worked out. Yeah, he's
Oh,
done.
rip. Peace be
he was-
upon your boy, dude.
Yeah, the guy was up in a
They're saying he had a
in
heart attack.
power sail. He was up there flying around with a power sail, just doing the tourist thing, and had a mechanical problem, ironically enough. And
Oh.
yeah, it came down rather fast. And the ground disagreed with his vector, if you know what I mean.
Oh,
Anyway,
yeah.
That Red Bull money dried up.
yeah, big time. Well, yeah, so that's a video that I produced on Felix. It's a two-parter. The first thing that I address in that video has to do with the GoPro scam. And I'm sure you guys know about it as soon as I mentioned the name. It's all about the big old fish eye lens thing where
Are you talking about that sweet baby Earth curve between Felix
Yep.
and
that
in space?
amazingly flexible Earth
Ah.
curve. It's yeah. So I actually take the time to pull a few frames out of his footage and graphically stripe across the screen as the Earth blows by from bottom to top, how convexity turns into concavity. And the line,
come on,
the
Stone.
line
GoPros don't do
between-
that.
I shit you not, my brethren. And the line between the two is exactly straight. The line that is formed when we look at the surface of the Earth, so to speak, shooting through precisely the midpoint of the focal point of that lens, taking the video, it's a straight fucking line. So that's the first half of the video.
That's one of my favorite types of lines.
I mean, I love it when it goes convex. Sorry, go ahead.
The second half of that video is all about the jump itself, the positions, with respect to longitude mostly, because interestingly enough, his actual trajectory when he left the airport runway, launched, he headed almost due east. And it's that thing. And I give credit to Dave Weiss for pointing this out first. It's all about R and altitude. That it's the same thing in this case. If you look cross-sectionally at the, quote, spherical Earth, when he leaves the runway and the winds have to be 0 at the surface in order to safely take off in this craft that has no propulsion whatsoever, it goes up, and somehow as R increases, where you would think with the same tangential velocity, he would lose position on the alleged spin of the Earth, which at that latitude would be something around 660 miles an hour. Somehow, instead of landing 6 1/3 miles to the west after being in the air for 158 minutes, he lands about 40 miles to the east.
What the ruck?
Yeah, it's one of my favorite videos. But what for me, what tops it off is another part of my typical style back then, and a little bit now. I have some audio running over the top of this from another flat Earth documentary called "Finding the Curve," done by an ex-gamer. I don't know if X, he's a gamer too. Anyways, and it's a conversation between him and his clearly at least partly drunk producer, talking about the prospect of filming a flat Earth video. It provides awesome ambiance, thematically speaking, to what we're looking at on the screen for the entire video. And we slam all that into all of, I think, 6 minutes or something like that. And I present all of the trig, all of the math, as I do the analysis of his flight. And then, of course, I pose the question at the end, how are the Globies going to explain this? It really is an enjoyable little
Dude,
chunk.
do you ever hear back from the Globies?
Well, there are 2 or 3 of my videos where guys like Roof Fentanyl jump in, and there are some other professional trolls on BitChute who are anti-flat Earth, and they come on with their copy cake. You know what copy cake is, guys? That's where they just pull large chunks of text that they didn't write and paste it in as argument against whatever you assert, without really giving it much thought as to whether the shit even relates to the issues at hand. But that's another issue. No, the answer in general, no, I don't see objections that amount to actual refutation to pretty much any of the videos that I've put up. I mean, I'm sure you guys remember the release party when I did the one, a couple of thoughts about Google Earth, where I talk about the cool little feature in Google Earth where you can get profile data between 2 points on land, and that it draws that profile data from the assumption of a flat Earth analysis, that it draws square transition from A to B, so to speak. It goes straight across the screen. There is no curvature to it, regardless of how large the distance might be between those 2 points. It could be 2,000 miles or 2 miles. There's the same curvature. And this is what I spend my time analyzing in terms of that proportionality and what they do not show in that function on Google Earth. Personally, I take that as, hey, there's probably a reason.
Stone, you know how people are into like, yeah, dude, I'm hunting for Bigfoot. And they're like, and everyone's like, oh, you're retarded. Like, there's no Bigfoot. You're like, bro, like, what are you into? What's your hobby? Oh, I'm hunting for Earth curve. They're like, what? What's that? Like, there's this mythological thing that supposedly exists at a rough approximation of 8 inches per mile squared.
Yeah, I'm looking for coherent, correct, globy assertion in the form of formula, in the form of measurement data, or anything else replicatable, falsifiable. And that's again where I tear Einstein a new asshole in regard to falsifiability of anything he said back in the early 20th century, starting around 1905, with his first act of plagiarism. Yeah, there's that.
The first time he plagied up.
Yeah. But no, I don't know if I have a favorite one, because I cover so many different aspects using the same theme. That, hey, this is what they're claiming, and these are the figures they're spouting, but when we plug it into the formulae, doesn't quite work out. And I'm putting it to them. Hey, Globies, why doesn't this work out? And when we do that, I don't see anything in the comments section under the video. Go ahead and check them yourselves, guys. Dozens and dozens of examples of exactly what I'm talking about, where there are no comments whatsoever.
Are you a flat earther?
It's not because I deleted them. Trust me, guys. Come on.
I'm a curvature
because
hunter.
Just about in every case where these trolls did put up an objection, of course, I respond to their objections, and I leave almost all of that up for people to read, because for me that's just reaffirmation of a confirmation of exactly what I've been asserting in the video itself. And again, if it were the case, we would hear from more globies, not just the same old 3 fucking trolls. You know what I mean?
More
But we don't.
globes.
I don't hear from them. It's fucking crickets, man. So yeah, I guess that's part of the reason why I'm here on nights like this, is because I'm looking to talk to some of those people who actually would take the time to objectively watch my videos that are so long, 4, 5, oh my god, 6, some of them are 9 minutes long, and formulate an opinion. You know what I mean? And offer it here. That
Oh
to
my
me
god.
would be some
You have
awesome fucking
9-minute
exercise.
videos? Holy
Believe
shit.
me, man.
I just realized why nobody watches my videos, dude. They're hours long. I wouldn't watch a 10-minute video if you fucking paid me. Fuck. Oh man, dude, I just realized the problem. It's us.
They're just too damn short. My bad.
Dude. Dude,
Yeah,
we gotta dude, if you can get it down to 2 stone, like I might take a Gandy, but 10, bro, like
2 minutes. That's quite the
Alan,
challenge.
just to
2
let you
minutes.
know, I do watch your long videos.
Due respect. Shout out to you.
Alan, just think, how long would a video that you want to watch be?
I mean, ideally, oh my god, Taylor, I never thought
About
of it
14
like that.
seconds
Yeah.
on 2.0 speed.
Yeah. Stone knows what's up.
Shorts,
Dude,
YouTube Shorts.
Dude, the fact that YouTube Shorts don't start on 2.5 speed is fucking insane, bro.
Alan is pissed because YouTube doesn't offer the convenience of a 2.25 speed, because sometimes you just have to hit that sweet spot. You
Oh
know what I'm
no.
saying?
Oh no, there's there's a
honestly,
mod for that, bro. I got that. I can dial it in, bro.
I live my life at 2, so being in here is like talking to turtles, I swear.
Here I just got done watching an 11-hour video on special relativity.
Oh my god, my condolences. You're never gonna get that time back, man.
Apparently, there's a point in time where I could get that back, but I have to be traveling at the speed.
It's like, dude, I see you learned a lot, bro.
No,
from that
you
video.
have to be traveling as fast as the universe is supposedly expanding at 4 times.
Well, I just have to go out a little ways and come back, and y'all will be dead, so it really won't matter.
That is the time dilation thing is the point that I spent the most time on when I was doing the couple thoughts about Einstein video. And I use a scenario, the famous sci-fi scenario that came out, a lot of 70s movies and shit, the cheaply produced B films, about a guy who gets tossed into the state-of-the-art spaceship, and then they send him off into space to some really fucking far away place. And it takes, in my little metaphor, it takes the guy a month to get to this other star or system or planet or whatever. And in base time back on Earth, that took 31,000 years. and okay, so let's say he gets there. The 2 points that I bring up are, one, all right, when he gets there, chances are people back on Earth during those 30,000 years probably figured out a faster way to get there, and they're already fucking there when he gets there. You know what I mean? So what was the point? Secondly, maybe that part doesn't happen, but he gets there, looks around, stays for a month or a year or whatever the hell, because it doesn't matter, and then he jumps back in his spaceship. He's got the hot news, and he goes all the way back to Earth, and it's 62,000 years later. Who gives a rat's ass what this guy did in his little spaceship 60,000 years ago? You know what I mean? It's so irrelevant to anything about a species.
You're awesome, Stone.
Unfalsifiable part. You know what I'm saying? Forget that it's totally unfalsifiable. Just like, why would we bother is the point, right? Yet there are countless sci-fi movies with that scenario in it.
Just need that warp speed, man.
I like the classic. You can go fast enough that you could be your own dad.
Hey. What's up? It's me. Oh, shit.
Oh no!
Oh shit!
I
It's
mean, it
me,
was
Papa. Like what?
What are you doing? You
Do
know
you
what
want?
I
Do you
did.
want? Do you want to hear the greatest troll of all
So
time? I think.
are you saying time dilation doesn't happen?
Yes.
Did you? What was that, Roundhouse?
Am I really broken up? What's going on?
You were
Yes.
just
You're
low.
just nowhere near your
Kinda,
mic,
you're
really.
kinda low.
Um,
But I was actually, I don't know. I just didn't hear what you did. You say? Did you say something about we don't believe in time dilation?
do I sound a bit better now?
Oh yes.
Hmm?
No,
Much.
we still hear you.
Oh.
So, Stone, are you saying time dilation doesn't happen? Is that what you're saying?
Okay, I think you should definitely watch my video. Again, all of probably 5 or 6 minutes long. It's not about do I think time dilation is real. It's about when are we as humans ever going to be able to test to see if it is. I mean, even what we're doing allegedly with the ISS.
With GPS
You know what I
clocks.
mean? Yeah, GPS clocks. Get me started.
Did someone
No,
say
no,
a
no.
gyps clock? Ooh, let me. We'll come back to
Oh,
that. We'll come
God.
back to
Yeah,
that.
Alan's gonna tear you a new
Whew.
asshole regarding GPS.
Oh,
No, it's like if NASA really wanted to prove time dilation, it's something that could be easily done just in our own orbit in a year's time. That here, picture this. You're up on the ISS, whizzing around the Earth at, whole bunch of 1,000 miles an hour. What you could do there is grab an atomic clock, 2 of them, in fact, identical, of course. And one of them, when you're blazing around the Earth, such that your actual forward momentum with respect to your orbital speed is at a minimum, you fire that clock out at a velocity where the net is that it stays in that orbital position relative to the sun as the Earth continues to go around the sun. Okay, you got me so far? So, in terms of the reference point of the sun, that clock is not moving. Okay, now the Earth is spinning around the sun, and it takes a year to go around to that spot again, right? And they could collect that clock and compare the 2 times, couldn't they? Couldn't they do that? I'm pretty sure they could do that.
No, they couldn't do that.
Okay, well, they claim to have satellites up there that have been up there for 10, 20 fucking years, still powered up, not torn apart by the more than 2 metric tons of debris that intersect the Earth at 20, 30, 40, 50,000 miles an hour every day. None of those particulates are eroding these satellites in the least, nor fucking with their functionality in the least. I think we could leave a stationary clock in orbit going around the sun there for a year, coated in lead or whatever the hell, lifts your skirt, and then come back and pick it up. You know what I mean? They could do that, but we're never going to see them do that. It's never going to happen.
I once saw an ambiguous picture.
The solar system's also rotating around the galaxy. The galaxy is rotating around the supercluster. The supercluster is. They now
So
think
what's that
the
got to
entire
do with the
universe
price
might
of fish?
actually be
What's the
rotating.
price of fish in China, my dude? Oh, dude, Stone, nice layup, bro. I saw that coming a mile away.
You got any more straw men in that hat?
You got no idea. You got no idea where I'm going to go with it, though.
You got
so
any
the
more
clock
straw
wouldn't be
men?
there.
Look it up,
We've moved a gazillion miles in space. By the time we go around the sun, that spot isn't the same spot anymore. The clock's not there. The clock's a billion miles
Okay,
back.
so let me back it up again because you do not understand what I described. All right. Okay. Look, from year to year, the sun.
To be fair, it really wasn't that hard. Drop the clock off and come back in a year's time, but we won't be there in a year's time. We'll be somewhere different.
Okay. Again, when you say that, you tell me you do not understand the scenario. Okay, you do not understand the vectors. So let's try it again. And start with the simple observation that the globies claim that the orbital plane of the Earth around the sun does not change from year to year. Right?
Yeah, okay. Right.
You got me now? So we're going to be on that same orbital plane next year in the same spot, aren't we? Relative to the sun's position.
Oh, so you're saying the clock moves with us as we rotate around the galaxy?
Like I said, with respect to the reference frame of the sun, for a year, that clock is stationary. You got me?
Okay, that's where I misunderstood it. Because why does that matter? That it's stationary in comparison, as per the sun as a frame of reference. Why does that matter?
We're talking about time dilation, right?
Right.
Okay, so the faster you go, for you going faster, time is actually going slower, right? That's why it only takes you
but
a
our sun
month.
is not sitting still.
No, it's not.
But our sun
The
is not
sun's not sitting
still.
still. No, the sun's not sitting
Okay.
still.
All right. Okay.
I don't care about that. I'm talking about it as a reference frame. Okay, a non-inertial. Actually, it's an inertial reference frame, right? It's not accelerating or decelerating. It's not curving around. It's blasting through space in a straight line, right? Still got you around? Come on, Randy, you can do it.
Yeah. I understand basic physics. You don't have to ask me if I understand every single thing.
In terms of the reference point, the Earth is blowing around the sun at 30 kilometers a second. The first clock that you fired out the window will not be doing that speed. It'll only be doing the speed of the sun. Okay, so there is a combined vector of movement that the Earth is doing that the clock will not be doing for a year, right?
Yeah. Right.
Okay.
Well, why do we
that
need to do
difference
that?
is 30 kilometers a second.
Right.
Okay. So for a year, with a difference of 30 kilometers a second, one to the other, when you come back and pick up that clock, it should be a very different time, shouldn't it? Well, the truth is it's only a couple hundred milliseconds, but again, plug in the formulae and you see what absolute stupidity these formulae actually mean in terms of real time.
That would be took a very long way to get to experiments that have already been done with atomic clocks at the top and at the bottom of buildings, and they're out by the predicted amount.
So are you talking about Pound Rebka and Pound Snyder, my dude?
Okay, Roundy,
I couldn't expect anything
what
less
you're doing,
that thinks he knows more than Einstein. Give me a break.
Roundy, what you're doing is you're appealing to possibility without providing me figure, and you're also demonstrating. Okay, Roundy,
I couldn't expect anything less that thinks he knows more than Einstein.
Roundy,
give me a break.
Roundy, what you're doing. And guess who
coming from the guy that says I need to go to Telegram to see the figures that I asked for when it comes to electrostatic gravity, right? I'm going to say you couldn't follow what I just got at then.
Was I just too much?
You said I'm not providing computational evidence, and I said from the bloke who couldn't provide me some numbers when I asked for electrostatic gravity, I had to go and look at your page. Right? Who are you to tell me I'm...
Oh, such a chore.
Hey, bloke. I asked you for some figures. You didn't give them to me immediately. Instead, you referenced a place where I can go find them all. Like
you bastard.
Hang on. But he just canned me for that. He just canned me for that. Are you guys fucking retarded.
I might be. I didn't catch that. If he did just double reverse you, dude, my bad. That's funny. But it sounds like, anyway. The important takeaway from this is that there was a lot of claims about relativity that were made. Oh. Doesn't Stone, are you done with this meal? Can I get some scraps?
Well, hang on. The only claims that were made here were by Stoner. Okay, I've offered you evidence that can be gone and found by anybody and can be tested by anybody and done yourself. Stoner has made claims that none of us can validate, and when he gets pulled up with it, he just laughs. He's not going to offer anything in competition to us.
Anybody can buy some atomic clocks and run them up buildings. That's for sure, buddy. Oh,
dude, I was about to say, dude, that's a good one.
Give me a break.
I don't even think the man knows what he said. But anyway, I see my boy Bruce Ferret is here, and I was about to dip, but like, do you want to talk for a minute, Ferret, or am I free to get off of here?
Oh, you can. Yeah, I want to talk to Stone about two things that he said.
Oh, a little Stone battle? Okay, well, I'll stay and listen for that, and then I'm going to get off for the night. Go ahead, lads.
So, number one, Stone went on a big rant about how sort of no Globers have engaged him and there's no comments on any video on BitChute, right? BitChute sends me an email. Yes, it is. Yes, it is. You said you don't delete comments.
No, that's not what I said, you dumbass.
Oh, let's roll back the tape then.
You go right ahead, because you will hear me say,
yeah,
you will hear me say that I nearly leave all the comments up.
Okay, except for mine that engage with you,
back all you like, guy, because you're fucking retarded. Do not take things out of my mouth and twist them around and shove them back in and pretend that I fucking said them. Okay, that is the worst
did you delete my comments?
I can think of.
Did you delete my comments?
Some, yes, I sure did.
Okay, thank you.
Do you see me denying that? No, I'm not denying that. Are you going to ask the question why I deleted your comments? Fuck no.
Because you got wrecked.
Yeah, yeah, says the anti-flat earther, man.
Okay, so you've admitted you deleted comments. That's number one done, right? Number one's done. Number two, let's address this fucking stupid idea of launching an atomic clock into space and coming back around, right?
Sure.
So to clarify, you're saying like we're moving in the orbit at like 66,000 miles per hour, right?
I'm not saying it. You guys are.
Right. Yes. But you're suggesting that we fire an atomic clock such that it goes 1,000 miles per hour and is in a stationary.
I'm suggesting it goes nowhere relative to the sun.
Right. So if we're traveling 66,000 and we shoot it off 66,000, it's 0, right? With respect to the sun. Correct?
That's right.
Okay. What the fuck is going to happen to that clock in a year?
What kind of question is
it going to be there? Is it going to be where you left it?
Of course it is. Relative to the sun's position, you dumbass. You're just as fucking retarded as Roundy. What is stopping
the Earth?
What is so hard to understand here?
What is stopping the Earth from falling into the sun?
Oh, for fuck's sake!
You got any more fucking orbit, you idiot? It's in an orbit. So what's going to happen to something that's stationary? What's going to happen to something that's stationary? What's going to happen to something that is stationary?
Well, hey, look, maybe you could modify the vector and toss it slightly away from the sun perpendicularly. And then by the time you come back in a year, it'll swing back to that exact position. Go ahead and factor that in. I don't fucking care. It's not going to change the fucking answer.
The answer is to fire it at double the speed, right? So that's actually going in the opposite orbit, right? And you meet it 6 months later, but it's going 130,000 miles per hour.
Bullshit. What are you talking about?
If you launch it from the Earth in the opposite direction at the same speed the Earth's going, you will meet at the other side of the
Did you not hear what I just said?
What?
You clearly didn't hear what I just said. And you're just going to ignore it and talk about shit I didn't say.
I'm waiting for you to say it, you fucking idiot.
And the usual bullshit you bring to the table every goddamn time.
How about you say it rather than not saying it?
I said again. Are you ready? Listen this time. Okay, instead of leaving it in the quote stationary position, launch it slightly away from the sun and have that come back and be at that where it would be stationary position on our
This
orbit
is the
by the
guy who
time we get
taught
back to it in a
Einstein a
year.
new one.
Modify your
Fucking
vector. That's a
hysterical.
simple piece of thing, and it has absolutely nothing to do with the point I'm making.
So I did hear it because I immediately said you've got to fire it at double the direction, double the speed in the opposite direction, and then you'll just meet it again in 6 months' time.
No, you don't fire it at double the speed or any other bullshit.
So you want to fire it away from the
in
sun.
a year at that position is the point.
Oh, geez. All right. So you fire it away from the sun, and then gravity brings it back to where you are. Correct?
Right. In a year. And you come around the orbital plane, like you guys claim exists, and you pick it up in a year at that spot where you launched it.
Okay. So how are we going to pick up something? We're traveling at 66,000 miles per hour. And this thing you've fired, away from the sun is also going to be traveling probably several thousand miles an hour as well.
No.
How exactly are we going to pick that up?
Oh my God. It's not any of it's going to happen. Don't you get that?
I agree, because it's fucking stupid.
It's also impossible because space is fake and gay.
Right.
The whole thing is
your idea.
If we can dock,
your idea is stupid.
I like that we just reached common ground here. Space is fake and gay, and we all agree.
All bullshit.
And why can we dock on an ISS going at 17,500 miles an hour?
Exactly.
Right, because we have rockets that accelerate to that.
Right. You just match the speed. What's the problem?
Do we have rockets that can get to 66,000 miles per hour relative to the Earth?
Why not?
It's a hype. Oh,
how the hell
yeah,
not? They've got all these fucking plasma drives. Go see my couple thoughts about plasma 2, gang. That's a very entertaining video.
If you can show me a rocket that can get to 66,000 miles per hour, I'd love to see it.
No
Changing the
comments
subject.
on my plasma page either. Hey man, he's the one who changed the subject and said, "Do we have rockets to go that fucking far fast, Roundy?" So let's bust the right guy, all right?
Because your idea is stupid. It's impossible.
Oh Jesus! Of course it's stupid.
Especially
I'm telling
when
you
you
why
can do
it's
what I
never
just
going
did.
to
Your
happen.
idea is stupid.
Put clocks at the top and the bottom of buildings, which we do, and the measurements are different.
God.
What the fuck is wrong with you?
Again, you're telling me something that tells me
Hang on,
you
I
don't
should
understand.
listen because you taught Einstein a new one. Okay, go on. Tell me why that doesn't work.
Well, it's not that. It's not
half
that.
an hour on that.
Yeah, it's not that the clock measurement doesn't work. It's just it's not mutually exclusive to anything. But we can go over that later. Just continue on.
Right. Really?
Like I said, there goes the neighborhood.
So what does do it? Do the fact you
Well-
think you taught Einstein a new one is just fucking hysterical.
Well,
Does do it? What an awesomely articulated question.
yeah. So under an ether framework, there would be a difference in ether density potential and elevation, and it would give the exact same clock reading because the clock reading itself isn't doing
Ether density potential.
Yes, there
Sure.
there would
I'm
be the
wrong.
same thing. Okay. It's a different framework other than a vacuous space-time bending and warping. It's like, dude, relax. Slow. I'm saying a difference in potential would cause the same type of thing, even under like whatever mechanism you would consider like actual gravity. The difference in potential would cause the same offset. So the measurement itself is done by Mossbauer clocks, and all that's doing is it's ionizing energy that it accepts at a certain frequency into a rate or into another frequency and to see if it matches. So it doesn't tell us if the speed of light is the same, which is what Einstein's theory is all about. It doesn't confirm anything about it. And the measurement, it can be explained under different ether frameworks. So it's not mutually exclusive to anything because it's just a frequency shift. Nobody measured the speed of light in that. For just to start off with the clock measurement differential, and then on top. Okay, sorry. Go ahead.
Go ahead. No, go ahead. Finish what you're doing now.
No, that was it. I had reached pretty much it on the Heflin or Pound Repka.
Okay, so as far as this top and bottom of the building experiment quote goes, finally, I would assert that you guys are overlooking conveniently a massive causal assumption here. And you are not isolating for it. Let's just put it that way. And I know you know what I'm talking about.
Yeah. He asked how I would explain it though, and like I have a different
No,
conceptual
I was
framework.
addressing Roundy. I know
Oh.
Roundy knows what I'm talking about. And probably fentanyl too.
No, dude, I'm dumb as dog shit. You know that. So explain it to me. What are you talking about?
You're telling me that the clock speeds are different at the bottom and the top of a really tall building, and you are assuming something about the cause. You are not isolating for it in this observation. You're saying, oh, the clocks are different, therefore we're spinning around as an Earth. And that is scientific
not that
bullshit.
simple. But what's your
It's
excuse for it? And
bullshit.
Okay, so what is the thing that I'm not accounting for that is causing it then? That could be causing it.
Well, geez, you're the guy who brought up electrostatic gradient.
No, you just said
Well, listen.
There's a massive variable that you're not including here, and you know what it is. I said, no, I'm really dumb. I don't know what it is. Why don't you explain it to me? So
well,
go
you
on.
know about relativity, right? Then you know about the factor about being in a gravitational field. It's not all about velocity when it's talking about Einstein,
Right?
Is it?
Yeah, go on.
Okay,
I'm still
great.
not following what you're getting at.
Fuck, you're beyond hope, buddy. You're tossing in shit that's just not relevant to what I'm talking about, and you're demonstrating that you do not
You're the one who's
understand
full
what
of
I'm
shit.
saying.
Yeah,
I've
dude, you
spent
can't
a half an
explain it.
hour
You won't
describing
explain
it,
it
and you
because you can't.
still don't. See, you
Someone
can't even let me
who's
finish my
right,
sentence.
someone who's right does not refuse to explain something.
I would
You
like
won't
to
explain it because
I would like to offer what Pound Repka and Pound Snyder thought it was. So when I mentioned earlier under like a classic ether physics framework, the predictions would be the same. The way that they conceptualize the frequency shift, like how it could be interpreted essentially, is that if light has a mass, the gravity would be acting on it, and it would change the frequency at the same proportional ratio that is predicted by Einstein, because it's like a really small, almost indistinguishable. So like I said, the measurement itself doesn't, like Stone saying, doesn't tell us anything about reality. We have to make assertions about the cause. For my assertion would be ether pressure differential. As you go up higher, there's more pressure. And then when for you, you're like, oh, well, it's gravitational potential based on mass and energy conserved into a gravitational field that's changing space and time over a 35 meter fucking over a 75 foot tower. Like that's one possibility for sure. And then Stone was saying that there was a gravitational potential, the electrostatic potential gradient that could cause the change. And it's like, we know that magnets and electricity can change the frequency of light. So to suggest that couldn't cause a frequency shift, it's like, that's just you're just saying like, nuh-uh. Like if the measurements come out equivalently, it can all be explained the same way. None of us are like necessarily correct, right? We'd have to do further measurements and predictions on that. The clock reading differential alone doesn't tell us who's the grandmaster of the fucking universe, dude.
Cool. Can I,
well, to make any of what you said, you said just then valid.
I'll be 5 seconds. Roundhound, I DM'd you if you want to chat. I'll be out. Thank you. See ya.
You Aussie blokes can't use our Flat Earth Hangout as a place to meet up and... No, I'm just kidding.
Anyway, DM'd you about stuff. Catch you later. See you.
Yeah, cheers, mate. I'll get to it.
Aussies.
Yeah, so for any of what you just said to be valid, you mass
pretty
being
robot-y there, man.
Particular volume of...
It's cutting out hard.
Yeah, you're roboting a little bit there, buddy.
Get yourself an ISP.
I'll just wait till I finish. I'll just wait till I finish packing up the job. It's going to be real noisy.
No worries, lad. I was about to hop off for the night. So I think I'll let you off easy, and we'll say that maybe Einstein's right. We'll come back to it another time.
Maybe, probably not.
I'll leave it on the table. He potentially, he could have got it.
Einstein was an op, and he sucked in the normies with it.
Dude,
Anybody who pays attention to the history back then and reads up on the 100 physicists who disagreed with Einstein back then, yet somehow his theory was pushed to the top. If you can't see that, there is no hope for you.
Needed space back, man. They had to go with them.
Dude, one of my favesies is you know how they always co-opt everything as like mutually exclusive proof. The Heflin Keating, or the Pound Repka paper, the first one is titled "What is the weight of a photon?" And they're like, "Look, guys, this is going to sound crazy, but here's the thing: you could work out what the weight would be based off of the frequency shift and the gravitational potential, and it would cause the same thing, or this could be Einstein. We make no assertions, about either one. Good luck with the interpretation. Catch you on the fleazy. Here's the data." And then they did the same measurement again with gamma radiation, so that it would be more, it would like isolate electric and magnetic frequencies, with just like experimental air, ambient stuff like that, because it's gamma radiation's neutral to that. So anyway, they do it with this gamma radiation to reduce the error in measurement, and they get the same exact thing. And they're like, well, again, boys, inconclusive. Here's the ratio for our explanation, and how it's equivalent. So if anyone wants to refute that, and then you know what, they gave those guys the Nobel Prize for proving Einstein's theory of general relativity. Like their paper isn't like they're like, it's not mutually exclusive, could be anything, good luck. And then they gave him the Nobel Prize for like proving it mutually exclusively. It's just like it's labeled as like a thing. And then also when you get into the special relativity corrections for an atomic clock and the general relativity corrections, what they end up saying is that they actually cancel each other out, because a bunch of engineers that worked on it for the Department of Defense, like on the back end GPS stuff that like we don't even really know about, because they have to make it super accurate and get all the timing correct. They were like, "Hey, quick question for you lads. Why aren't we including any relativistic transformations? There's like my boy Lorentz transformations not here. And there's no way to adjust the timing stuff. And all we're doing is just calculating for the Sagnac effect, which is just relative motion to the ECEF, which is, in other words, saying all motion relative to the Earth is what we're accounting for, and like a one-way difference in the speed of light. So it would be nice to figure out what we're supposed to do with that, because relativity is supposed to be the transformation of choosing, and we're doing Galilean transformations. So I don't really know what to do here." And the response was, to the engineers who were asking that, was, "Hey, listen, lads, let me show you something real quick here. The general relativity correction offset speeds up the clock, and the special relativity one slows it down, and it's within like 14 or 12 nanoseconds or something like that. And you don't need we don't need to be that accurate. It doesn't it's not within it's not worth accounting for, but one day in the future, maybe we'll definitely incorporate it. Just hang tight." And then, like, let's see, after that, so that was 1998. And then in like 2006 to 2014, there was a guy named, not Ron Hatch, but his buddy, or not his buddy, but his rival, I guess you could say. Who's the fixer for GPS? Can't think of his name right now. But if you Google GPS Sagnac effect, it's the first name that pops up. It's that guy. He goes on like a 20-year tour telling people that GPS and the Sagnac effect are proof of relativity, and all this clock corrections and all this stuff. And then he goes in to show what the internal transformations that they use for the ECEI to ECEF, and it's a straight up Galilean transformation, my dude. They're just doing absolute time values in when they're supposed to be doing relativistic physics, because Einstein's super correct. And in all GPS shows is that all motion's relative to the ECEF, and that the speed of light has to be accounted for, because it'll change relative proportional to the velocity of the observer. It gets crazy out there in the streets when you look into GPS, dude.
And all of this started, I will state as a postscript to everything you just said, Alan. When you started with the paper regarding citation of the mass of a photon.
Yep.
I am consistently astounded to see how willing globies are to just blindly connect formulae that pertain to energy calculations, EM included, mostly EM, of course,
to mass,
and formulae which pertain to matter. And they take the two sets of formulae and jam them together and pretend that they're seamlessly integratable. And it's such a load of bullshit. I really don't know how these people can call themselves scientists when they aren't actually literate, even to that basic degree.
Oh, dude, they got EMC squared out of their minds, so like that's why they're like so apt to do it. And
Yeah,
real quick,
no doubt.
and real quick, shout out to Kat. The name of the GPS lad that I was looking for that tried to co-opt the Sagnac effect as a relativistic effect while using Galilean transformations on the back end the whole time. His name is Neil Ashby.
Ah, very good. Go Kat. Yeah, I think it's time some code names, man. I really gotta.
Yes, code names. I see Toby in the chat, dude.
When hostility meets ignorance the way it has this evening, I gotta take a breather. It's just one of those things. Mental health precaution, I guess.
Well, before you check out, you had your hand up for a while, Aurelian. Did you have something? And I see Mr. Xavier. I think Mr. Xavier.
Yeah, Xavier's got his hand up too. Yeah.
Yeah. So I think he has a question.
This as long as I fucking did, but before it got a little bit above my head, someone was pointing out just how to deal with people. And so it brought me back to like Sydney and Peter and the people that we deal with that invoke the same fucking bullshit all the time. So like typically what ends up happening is they come in hot, arguing with you, okay? Like just with the Sydney and the fucking refraction of shadows thing. You got to be able to figure out how to point out that they're applying something that may be relevant in a different observation, but is not relevant in this particular observation. So like what they'll do is they'll come in hot, they'll invoke some shit that could have some relevance in a different observation, but try to apply it. It's not applicable at all, but they're going to try to fucking hammer the point home and make this as applicable as humanly possible to try to make it a gotcha moment. It'll never be one, but they will waste your fucking time for hours arguing on the same fucking thing, trying to make you chase your tail. So I think one of the things that I was paying attention to with the way that Stone lays things out is you got to be able to find a way to be like, look, dude, no, you're not wrong, but you're not right. What we're talking about here makes you incorrect. You're trying to apply something that's not applicable in this particular observation, so move around. I mean, fuck, that being said, the only other thing I had, and like I said, I can't believe I held on to these this long, is that Felix Baumgartner thing, man. I remember watching it live when it happened. And so like the whole, I'm going to watch Stone's video. I would recommend everybody does it. I have not seen your video, Stone, but I will watch it. But this was something so right after watching it live. I mean, you watch the guy go up, and we're just talking about the cameras, right? Because it needs to be two parts like you laid it out. Let's just talk about the fucking cameras. I mean, it's fisheye GoPro lenses the whole way up. It's bobbling around. The capsule opens, and you get a view from behind his head. And it's a completely
classic, isn't it?
Literally like, it's like glass. Okay, it's like the stillest water you've ever seen. So you're like, okay. Then he hops out of that motherfucker. I happen to be from New Mexico. I know exactly where he launched. And you get into where it was predicted that he might land versus where he actually landed. It was in the absolute wrong direction in accordance of, I don't know, the way the earth spins. So we got that. So dude, I don't know. It's fucking, the gaslighting never ends.
Does anybody find anything noteworthy, notable about the fact that all of this took place? The launch site was at Roswell Airport.
Oh, yeah, classic CIA got us again, dude. Hilarious.
I thought it was ironic, but I mean,
just thought I'd put that out there, you know?
no, but at this point, Stone, like, what, like, are you surprised by any of this shit anymore? I'm not. It's just like,
Not in the least, bro. Not in the least.
on your face, they're just like, okay, so we're hitting you in the mouth with this rubber dick right now, and you're just gobbling it up. But here's some Red Bull and some GoPro shit. You feel good? And everybody's like, yeah, we feel great. Okay,
The colors
moving
are
on to the
awesome.
next.
It's so red, white, and blue. How would they not love it?
Oh fuck. So, anyways, now I'll land it there, man. I'm surprised I held on to that as long as I did, but I mean, you described it. I tried to dumb it down, man, for people that, you know, I mean, we're you know, some of us are 101, some of us are you know, you and Alan and fucking Toby and Shane, and you know, we
We're
appreciate
201. Okay, great. But I thought you showed excellent restraint. Go
I just work here, bro.
you guys putting in the work you put in, but I'm just saying, like, sometimes, you know, the simplest way to describe it is best. And these people that waste your time, and I always want to point out how important that is. Don't let them waste your fucking time. You only have so much of it. You don't even know how much you have. Don't let them waste your time. If they keep coming.
Did I just get Twittered? Hello? Testing?
Mic check.
Yeah, you're clean, man.
We got you, bro.
A little louder than good, but go for it.
Nice. No, I was gonna just tag on to what Stone and Alan were talking about. I mean, I'm surprised that they were having so much troubles with this thought experiment because, as we know, they claim their GPS accounts for this dilation. So, Stone prolonging the process by giving them a longer duration in orbit. I mean, what was describe the problems with the setting clocks in motion? Right? So the reference with this
man, we're kind of losing you there.
Remember that one?
I lost you there.
Oh man, it sucks. Test.
There you are.
Well, I'll shorten it up. I'll shorten it. But if you look at the NES, if you get some time, the paper goes over why there's a problem with the synchronization of the clocks, where you got to pick a frame and be consistent with it. You can't pick non-Galilean reference frames and then translate it into Galilean, right? You can't go hop back and forth, right? So that's that.
Well, not without one of them cool tensors, you can't.
Right, them tensors, which I learned more about, which is pretty much warping and bending a graph grid on top of reality, soon to come. But the last one is pretty much you can interpret.
Ooh, Xavier speaketh the tensor language.
Yo,
nice.
Bro! I
just thought I'd probe it a bit.
nice.
Bro, but I've been having sidebar conversations with Ken. You're gonna love this stuff, but you and me, I gotta double check, triple check just to make sure things are in order. But in short, time dilation could be interpreted as mechanical effects of setting these clocks in motion relative to that ether that Alan was talking about. And if you have some time, go through the Vimeo link. I'm gonna take Ken's suggestion and breaking down the math step by step, because I've done so with something else that he suggested, because Franco was jumping in one of the comments that he was sparking out, and he says, why don't you just go through the step-by-step process? And I did so in a gift. I'm like, yeah, why don't I just do that? And lo and behold, crickets after that, because that's speaking his language, and we're just pigeons after all, right? So I'm gonna
just mere mortals. You're just a man. Einstein was a number. Numbers are forever.
Right. So
damn it, man.
So we can get these numbers that have real life reference, right? We can quantify how many fairies are in the universe, or we could quantify actual things with substance. So we can bring that back using their language, because we don't shy away from math. We don't like to reify math into existence, right? There's a difference. There's a huge difference in that. So when you're not thinking of light being a particle wave duality that's violating laws of logic and theory, so they'll say light is a particle that acts like a wave, et cetera, if you can understand how it performs as a wave, but it's a perturbation of something that needs to exist because you need something to carry this propagation, you could understand these different interpretations. So that's soon to come, but I just wanted to leave that in the nest if you guys wanted to have a preview in the meantime. I'll end it there.
Xavier, you're so awesome, bro. You know what
You
my
too, brother. No, you the man. No,
you know
the man.
You know what my favorite part of absolute differential calculus is, bro?
What's that, bro?
When you set the input and boundary conditions, like basically when you decide you're done playing Dungeons and Dragons as a character and you want to be the DM, when you pick up the Dungeon Master book, you set your own you are your own, you're your own Dungeon Master.
You are, bro.
Yeah, so I like it's very alluring, and you could see the like how that impacts like the level of prestige and some of these people have for these abstract concepts. It's like, what's his name? Franco won't even talk about general relativity because it's like a sacred thing. It's like, bro, it's retarded. You set the parameters you want and need, and then the output is what you get, like, what it has to be. And if it's not, you just change how you linearize down the nonlinear equations to like, it doesn't, like, dude, oh, dude, like, it's so stupid. It's
you're
like
talking like a.
Go ahead.
You're talking like a flatlander who doesn't understand the 3 dimensions, man. Just like we don't understand the 4th dimension. You don't understand it, Mr. Flatlander. So get your head out of your ass.
Dude, you know what it reminded me of? It's like when you have you have like a concordance for biblical reference, so you can like know exactly what a word means or whatever. And then you're like, hey, look, this word means that. And then some guy's just like, nah, I can make it whatever word I want though. And it means that. And then that's what it's always meant. And only my thing predicts what it really means. Therefore, I'm right and you're wrong. It's like it's preposterous what they can do with math like that when they set the boundary conditions, bro. When I found out like how you solve the like one of the metrics that they use to quote unquote prove their conceptual model for Big Bang, like you have to assume the mass and input of the universe and everything to like backwards derive how it would scale out as like a homogeneous heating and cooling thing, so they could get what they observe now to like backwards. Like, bro, your input was what you observe now, and you're talking about making like a smooth gradient backwards in time to infinity or whatever, essentially, and you're impressed that your calculation works. Whoa, dude.
Don't even get me started on the deceptions around mass, man. Cooking the books with mass is no joke. It happens so many places that we're not even aware of. Franco actually mentioning something got me diving into something deeper, and then I was like, wait a minute, where are the dynamics in all this? All this stuff is valid, but where are the dynamics? And when you go into that part of it, you're like, oh, there is none. So when you bring that to his attention, he goes, well, where's your dynamics? Whoa. We're just one thing at a time.
It's like, whoa, you're the one that thought you had dynamics. How about that?
Exactly.
I'll show you mine.
Show me your dynamics, I'll show you mine.
I already know where I'll show you mine if you show me yours.
No, that's crazy. We know Einstein had a problem introducing the concept of mass energy equivalence because it's like it's not even derivable in any meaningful way. And like they got stuck with it, and so he was running into solving conservation laws, especially in general relativity. And so what he was like proposing was like, hey, you know what? Can we go back to like rest mass and then just have like a different thing for this? Because all the funsy stuff they do with their relativistic mass and relativistic speeds and relativistic contraction and all this DS. It has to be backwards compatible with what's actually measured in the lab. So they have to always reference actual rest mass. So like none of the role play mass matters. Like it's like, oh, I made it a different mass, and then but because I can relate that also to what it was on on Earth in the lab, that must mean I'm correct, even when I'm doing scenarios where things are moving at relativistic speeds at distances no one's ever been to. Like like think about that, dude. Like you guys know what a manifold is, dude?
No, but algebra permits him to make that substitution, so it's okay.
Yes, he's allowed.
But the algebra has different properties. Sometimes when you're canceling out two sides of an equations, that algebra represents two different reference. So it has the same letter, but it's two different. It's very sneaky.
So handy.
Well, you know what they say.
What's that?
No, we don't.
Yeah, good stuff though.
Right on, boys. We just hit 1 a.m. my time. Time to change the channel, I think. But it's been a blast, as usual.
Later, lads. I got to check Prezi in a couple of hours, so I got to get to work on the old spreadsheet. See you guys on Discord, though. Be hanging out there while spreadsheeting.
That's a fact.
Sweet.
Hell yeah. I'll catch you guys. I'll be catching up here, and we'll connect more often. Stay off my job site with your fucking bear paws, bro.
Dude, stay off my wilderness land where I wander around in bear form.
But it just got to be built, man. I'm tired of seeing those fucking footprints, dude, making me nervous. I got to bring a flare gun.
Well, it's like
and a bear.
It's like they always say, does a bear shit on a bridge job site that construction workers are working at?
Occasionally.
You can walk down and knock.
If a bear shits on your website or job site, does anyone see it? Or I forget how the tree in the forest thing works. But anyway, good night, guys. I'll see you guys tomorrow, and then the next day, and then also on Monday. I'm not going anywhere. Dang, I'm going to see you guys forever. Bye.
Forever, man.
It's like we live together.
Dude, I just realized that's going to be a back-to-back-to-backer. All right, later.
Right on, Rudy. All right,
fucking header.
All right, lads, let's check out the chat for the boys. Shout out to Run Boston Bear, came in with a super chat on the back end. And then also there was one from Sun. Shout out to Sun. Much appreciated, lad. That is super awesome. I will see you guys. What are we doing tomorrow? We're doing check. Well, today, actually. Today's now. So in a couple of hours, we'll be doing a check Prezi. I'll be going over an update for the spreadsheet here. So hopefully before now in the check, lads, this looks like something everyone can interpret besides me. And it also has an analysis column here to go over everything. Like the meaningful stuff over here. So, and then I can take that and convert all these columns into the better representation of what I want it to look like. All right. So let's see here. I think that about wraps it up. And then we'll see you guys on Sunday, where I'll be doing the exact same thing all over again, presenting it on Glowbusters. And then Monday, guys, you're not going to believe what I'm going to present on Monday. Same exact thing, boy. Peace. For the Celestial Theodolite Update 14. And then Tuesday, hopefully Shane will have a presentation for Aether Roundtable 95, I think it'll be, or 96. And then we will go from there and see what happens.